since it starts on 100 here, we have to say to our while loop that the execution of this block of code here really has to stop when our counter comes to 500 or 501. 500 is still valid value. So that we are going to say like this. So we are going to say counter like this. And then we are going to say there are two ways to write this condition. The first one is to say while our counter is less or equal to 500, or you could as well set while our counter is less than 501. So that is a valid situation while you're executing your loop. So while your counter is less than 501, or while your counter is less or equal to 500. I prefer it this way, but whichever way you put it is going to work. So now that we have put this condition here, we really can write out this code that comes in this while loop block. So what we are going to execute while this condition here is true. And that is going to be following. Inside this block of code here, we really have to check whether our current value of our counter is divisible by 3 and by 5. And if it is, we have to write out that number to our user. If no, we just need to continue to our next iteration of our loop. And how we can check whether this counter value can be divided by 3 and by 5? Well, we use modulo operation for that. If you haven't watched my video on operators, I'm going to link it here. Make sure to watch it. And here we really put the following. So we can say if, and also if you're not familiar with if statement, going to link it here. So if our counter value, so our current value of our counter, after you modulate it with 3, if the result of that is 0, that means that our number, so our counter, is divisible by 3. And we also have to check whether our counter is divisible by 5. As well, we use this modulo operation here. And we say whether our counter modulated by 5 is going to equal to 0. And if this condition here is fulfilled, we really have checked this part of our task. And if this part here is true, we have to write out that number. So in this situation here, I'm going to say cout like this. And I'm going to put inside here, let's see, we are going to write out the value of our counter like this. And we are going to write out is divisible like this. And let's put one end line after this line of code here, because we are definitely going to have multiple lines. So we want our lines to be formatted nicely. Okay, so this part of code here has really covered this divisible by 3 and 5 and write out that number if it is divisible by 3 and by 5. And there is really one very important thing that you have to keep in mind each time that you write loops. And that is the following. So you have to give your loop a way so that it can stop executing this block of code here. So under a certain condition, it really needs to leave this block of code here, because if you don't do that, you are going to end up with an infinite loop. You are really going to lock your program in an infinite loop situation. And this code here, this loop here that we have written, this is really an infinite loop. So let me prove that. I'm going to run my program, and as you can see, the console is empty. So I enter any value, enter whatever, it is not really reacting. And why has that happened? Well, your counter value starts with 100, and then it comes to your while loop, and your while loop checks this condition here. So it checks whether your 100 is less or equal to 500, and the answer to that is yes, which means that your program execution can enter this block of code here, so it can start executing your loop. And then it comes here, and it says, please check whether my counter, which is 100, is divisible by 3, and the answer is no. So this part of code here is not even going to be checked because of the nature of this AND operator. It really needs both of these operands to be true in order for this expression here to be true, because this here is not true, it's false. 100 is not divisible by 3. It is not even going to check this condition here, and this line of code here is not ever going to be written. So after that, it comes here to this closed curly brace, and then because of the nature of while loop, when it comes here, it really goes back here. And then it checks again your value of your counter, whether that is less or equal to 500, but nothing has changed. Your counter value is still 100. And then it is going to enter again here, and then really repeat that process over and over again. And your program, because of that, is going to be locked inside an infinite loop. So let me prove that really, because here we have an empty console and you cannot see what is happening in the background. So I'm going to stop my program and I'm going to write out here, let's write out cout like this. And let's write out infinite loop. And if I run my program now, as you can see, your program has really entered in an infinite loop, and it is writing out this infinite loop text for infinite number of times. So as you can see, it says infinite loop. Okay, and this execution here is not really going to stop until your program's memory is full, and then it's going to crash. So whatever code indicates that you had some code here, it is not ever going to be executed. So I'm going to stop this here, and I'm going to delete this part of code here because we don't really need it. What we need is we need to put here a certain code that is going to help our loop to really stop the execution at a certain point. And the code that we need to put here is going to be really following. It's going to be counter plus plus, like this. What this code here is going to do, in each iteration, it is going to check whether this condition here is true. If yes, it is going to write out this part of code here. And then in each iteration, it is going to really increase the value of your counter by 1, which means in your first iteration, it's going to be 100. After that, it's going to be 101, 102, 103, and it is going to really go until it comes to 500. That is going to be the last iteration of your program. And then when it comes to 501, this condition here is not going to be true anymore. And then your loop is going to check really whether 501 is less or equal to 500. And the answer to that is not going to be no. So your program is going to really stop the execution of this loop and come here and then really stop your program. So if I run the program now, I'm going to prove that. Okay, so this has been executed very fast. And as you can see, this is the result of your program. It has really written out all the numbers that are divisible by 3 and by 5. And you can check all of these numbers using your calculator if you want. So with this expression here, with this counter plus plus, we have really both iterated through all the numbers between 100 and 500, because we check our counter value here. And then also we have really given a way to our loop to stop the execution of this block of code here when this counter value comes to 501. And this is the result of our program. Okay, so I hope that you have liked this video. Any questions that you have, write those in the comments down below and I'm going to answer those. Make sure to subscribe to my channel and share it with all your friends, anyone who would like to learn programming, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. Today I want to talk about while loop, and I have already made one video on this topic, and if you haven't watched that, I'm going to link it here, so make sure to do so. And why I'm making this video, because I really believe that watching one video and doing only one example is not going to be enough for you to really master a certain concept. It wasn't for me, it is not going to be for you as well, and that is completely okay. So we are going to show you how this while loop is used on one more example. And the program that I want to build today is going to be a program that has to count how many digits the number contains. So our user is going to enter a number, and then we are going to write a program that is going to count how many digits there are in that number. So let me copy the text of that program like this. And it says count digits of a number. So let's do the first thing that we know that we have to do and that we know how to do as well. So that is going to be write out a message to our user so that he enters that number, and then also allow him to enter that number. So I'm going to say cout, and then I'm going to say number like this, and then I'm going to allow my user to enter that number. Before I can enter it, I have to really declare a variable that is going to hold that number. So here I'm going to say int number like this, and then here, after we have written out this message to our user, we are going to say cin number like this. So after our user has entered his number, we really have stored it in our number variable, and now we are going to write out the program that is going to count the number of digits of this number here. So let's first see one specific situation that can happen, and that is going to be when our user enters number 0. So this number holds a value of 0, and in that situation I'm just going to write out a condition. So I'm going to say if my number like this is equal to 0, in that situation please just write out a message to my user like this: you have entered 0. Okay, like this. And I don't need semicolon here. This looks better. So this here is a situation where our user has entered number 0. And in that case, we just want to write out that he has entered 0. And now we are left with the main problem of this task, and that is to count the digits of the number that our user has entered. And that part I'm going to put in my else block, like this. And if you are not familiar with if-else statements, make sure to watch that video. It's going to be linked here. So here in this else block, I want to write the program that is going to count the digits of a number, which is not 0 definitely, because if we come here, then our number is definitely not 0. So how we are going to do that? Well, let me show you the algorithm on an example. Let's say that our user is going to enter a number 1325, for example. That is the number that our user enters. So how we are going to count the digits of this number? Well, first we are going to have a variable that is going to be called counter, like this. And initially we are going to set the value of that counter to 0. So that is initial count of our digits of number. And then we are going to use while loop to iterate through all the digits of this number. And in each iteration, we are going to do following. So we are going to come here, and then we are going to say, okay, take this last digit of my number and really remove it. I don't need it. And as well increase the number that my counter is holding. So increase the number of digits because we have removed one digit. And then in the next iteration, we are coming here and we are as well saying, okay, so take that last digit and increase my counter like this. And then in the next iteration, take the last digit, increase counter, and in the next as well, take last digit, increase counter, and then when we come next time, we really have nothing more to count. So there are no more digits left. Our number at this situation here is going to be equal to 0, and then we are going to know that there is nothing else to count. And then we are really going to leave our while loop, and we are going to write out the value that our counter variable is holding, which is at this situation 4. So let me show you how we can do that in our code. So I'm going to delete this part here. We don't need it anymore. And then here I'm going to write out the following. So as we explained already, first thing that we need to do is we need to create a variable that is going to be called counter, like this, or digits counter, however you prefer. And that variable, I'm going to assign a value of 0 initially. And after we have created this variable here, now we need our while loop. So while, like this, and then inside these parentheses here, we really write out a condition that our while loop is going to check each time that it wants to run, each time that it wants to iterate. And that condition here is really going to be, please check whether my number is greater than 0. Okay, so in any case where our number is greater than 0, our while loop is going to execute this block of code that I put inside these parentheses. And what we are going to put inside these parentheses, well, as we already explained previously, first thing that we need to do is we need to say number is equal to number divided by 10. And what this line of code is going to do, well, let me show you that on an example. Let's say that our number, so our number holds a value of 1, 2, 3, like this. And this line here really says the following. It says, please do this expression here, so calculate it, and whatever this expression here results in, assign that to my number variable. And 1, 2, 3, so 123 divided by 10, because this here is whole number, so it's integer, and this here is whole number as well. The result is going to be whole number, and that is going to be 12, or 12.3, but because the result has to be the whole number, that 0.3 part is just deleted. Bye-bye. So then this 12 in this situation is going to be assigned to our number variable. Okay, so that means that this number divided by 10 is really going to take away that last digit, which we have previously explained. So I'm going to delete this part here. Okay, and this line of code, there is really one more way to write this. So write the same thing. So I'm going to comment this here, and I'm going to write out number divided equal, so number r, like this, 10. Okay, so this line of code here and this line of code here are exactly the same. This is just a shorter way to write this here, and this looks prettier to me, but you can leave whichever of these two you prefer. Okay, so after we have taken the last digit from our number, what we are left to do is to increase our counter variable by 1. So we can do that using our increment operator here. So this part of code has really, in each iteration, taken away 1 digit and then increased counter variable. So what we should do now, after our while loop finishes, we should really write out how many digits our number contained. So we are going to write out count number contains, like this, and then let's write out the value that our counter variable is holding, like this. What is this? Oh, it says count instead of cout. Okay, and then let's write out just digits, like this. Okay, so our number contains whatever our counter variable is holding, digits. So now I can really run my program, and let's do that. So it asks us to enter a number. Let's enter number 1, 2, 3, for example, and it says that our number contains 3 digits, which is correct. So let's very quickly explain one more time how this has happened. So I'm going to stop my program, and I'm going to say here that our user has entered number, let's say 1, 2, 3. So our program in this situation comes here to our while loop, and it says, please check whether the number that our user has entered is greater than 0. And that number is 1, 2, 3, so 123, which is greater than 0. So then our program can really start executing this while loop. So it enters here, and then it comes to the first line of this while loop, and it says, please do this expression here. And this expression here really just takes the last digit of our number away. and that is going to be 3, so we are going to take that away. And then the next thing that needs to happen is increase the value of our counter. Since previously the value of our counter was 0, now the value is going to be increased by 1, so that is going to be 1. And after that, our program comes here, and because of the nature of the while loop, it goes back here. It checks again whether our number is greater than 0. Our number is 12 now, so the 1 digit has been taken away. So that is still greater than 0, so then our number really comes here, and then does this line of code again. So it says again, please take away 1 digit from my number. So then it takes away this 2 part, and then it comes here. It says, now increase my counter because you have taken away 1 digit, and that is going to be 2 now. After that, our program comes here and then goes back here, checks whether our number, so whether our 1 is greater than 0. It says yes, and then it comes here and it says, please divide my number by 10, so take away that 1 digit, so that 1 digit is taken away, and we are left with 0, and then our counter is increased by 1, and then we are really going to come here again, and then our program goes back and says, please check whether my number, so whether 0 is greater than 0, and then our program says, no, it is not, so our while loop is not executed anymore, and then it comes here instead, and it writes out that our number contains 3 digits. And there is one more situation that I want to show you, and that is going to be what is going to happen in a situation where our user decides to enter a negative number. So let's run our program and let's see how our program is going to behave in that situation. So now I'm going to enter a number of -335, for example. And you see that our program writes out that our number contains 0 digits. Why has that happened? Because our program has come here, so it has increased our counter. It has actually assigned our counter a value of 0, and then it has come here and it has really tried to check whether our number is greater than 0, but because our number is -335, that is not greater than 0, so our program then really is not going to execute this block here, but it's just going to go here directly. So then it's going to write out that our number contains, and the value that it has assigned to our counter here, which is 0, so our number contains 0 digits, and that's the message that you see here. So that is the explanation of this behavior, and we need to solve that now. How we are going to solve that? Well, it's pretty simple. So here, when we come to this else block, in this situation, in this 14th line of code, we are really sure that our number is not equal to 0 because we have checked that here. But here we really don't know whether our number is less than 0 or greater than 0. So here we really have to check whether our number is less than 0, and if it is, we really need to get the absolute value of our number, which means if it is negative, we have to convert it to the positive number. So here I'm going to write out the following condition. So I'm going to say, please check if my number is less than 0, like this. And then if this here results as true, I'm going to write out here a way for my program to convert this number, in case that it is negative, into a positive number. And how we can do that? Well, we can really multiply that number by -1. So we can say number is equal to -1 times number, like this. Okay, so now if I run my program, and if I enter value of -236, for example, our program now writes out that our number contains 3 digits, which is correct. So how has this happened? Our program has come here. It has really checked that our number is less than 0, and then it has come here and it has said, please do this expression here, and then assign that to my number. So -1 times -236, those minuses are going to really convert into plus sign, and then 1 times 236 is going to be 236. And after that, we are going to do the same logic here. So we are going to write out that our number contains 3 digits, which is correct answer. Okay, so that is the one situation that I wanted to explain. And there is also another situation that I want to explain to you, and that is what is going to happen in the following situation here. So let's see. Let me enter a number that is very, very, very large. I cannot even read this number here. So how our program is going to behave in this situation here? Write it in the comments down below, please, before I execute this here. And now if I press enter, what is going to happen? Well, our program has glitched a little bit, and after that it has written out that our number contains 10 digits. But this is definitely more than 10. Why has this happened? If you are not familiar with data types and overflow and concepts that I have already talked about in one of my videos, I am going to link that video here, so make sure to watch that video. And now I'm very quickly going to explain what has happened here, but make sure to watch that video. So when we have entered this number here, let me stop this program and let me put, let me put a breakpoint here, and now I'm going to run my program. And what this breakpoint is going to do, it's really going to stop the execution of my program at this line here. And we haven't talked about breakpoints or debugging programs previously, but if you want me to include that in one of my next videos, make sure to write it in the comments down below, because I really believe that it is important for you to see how your program is executed line by line, so to be able to follow it. And in that way you can really discover any bugs and any situations that are tricky and that are happening inside your program, so you can see and control that better. So I have put here a breakpoint, and let's now enter a number that is going to be a very large number. Okay, so if I press enter now, you see that my program has really stopped the execution here on this line here. So after I have entered my number, and then even though I have entered a number that is pretty large, let's hover over this number variable. You can see that it is holding a value of 2,147,000,000 and something. So this value here is definitely not equal to this value here. But because our program has really gotten the value that is much larger than the maximum value that our int variable can hold, it has really assigned the maximum amount that our int can hold to our number variable. So that is what has happened in this program. And if I click continue now, you can see that our program writes out that our number contains 10 digits, because it really was holding a 10-digit number. So that is the maximum amount that our int type can hold. Okay, so that is the last situation that I wanted to explain to you, and I hope that you like this video, and if you have learned something new, make sure to subscribe to my channel, share it with all your friends, anyone who would like to learn programming. Thanks for watching, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And first things first, make sure to subscribe to my channel and hit that bell icon as well, and share this video with everyone. It really helps me to reach a lot more people. And in this video, I want to show you how you can reverse a number. So your user is going to enter a number, and what we want to do is we want to write out that number in reverse. So reverse the order of the digits of that number. And here I have opened my Visual Studio, so let's copy the text of this task like this. And the first thing that we need to do is we need to really create a variable. So let's say int number like this, so that our user can enter his value in this variable here. So let's write out a message to our user. So let's say cout number like this, so that our user knows that he should enter a number, and then let's accept that value in our number variable. Oh, number, like this. Now, after our user has entered a number, let's really think about how we are going to solve this problem. Okay, I get it. So the first thing that I notice here is that we are missing a variable, and that variable is going to be the one that is going to hold our reversed number. So let's declare it here. I'm going to add it here, and I'm going to call it, let's say, reversed number, like this. And I'm initially going to assign it a value of 0. Okay, and now the algorithm that we are going to use in order to solve this task, in order to reverse our number. So the algorithm that we are going to use is going to be the following. So this reverse number here, it is holding a value of 0 initially, and this number here is the one that our user enters. So let's say, for example, that our user enters a value of 123, like this, so 123. So how we are going to reverse this number here? The algorithm is going to be following. So we are going to iterate through this number here, so all the digits of this number here, we are going to go through those, and in each iteration we are going to do the following. So the first thing is we are going to say, please take this reverse number and multiply it by 10. So 0 times 10 is going to stay 0. After that, what we are going to do is we are going to take this last digit of our number that our user has entered, and we are going to add that number to our reverse number. So 0 plus 3, and that is going to be equal to 3. And after that, we are going to really remove that last digit of our number. So I'm going to delete that digit. And then in our next iteration, what we are going to do is the same thing. So we are taking this reverse number, we are going to multiply it by 10. So I'm going to say 3 times 10, that is going to be equal to 30. And after that, we are going to take this last digit of our number, and we are going to add that digit to this number here, so to this reversed number. So 30 plus 2, that is going to be equal to 32. And then we can really remove this last digit here, so I'm going to delete it. After that, we are going to the third iteration, and we are doing the same thing. So we are taking this reversed number, multiplying it by 10. So 32 times 10 is going to be equal to 320. And then we are taking the last digit of our number. This is this one here. And we have to add that digit to our reversed number. So 320 plus 1 is going to be equal to 321. And after that, as we did before, we can really remove this digit here. And then in my next iteration, we are going to come here again, and our loop is really going to see that there is nothing else left to iterate through. So there are no more digits. And then it is really going to leave that loop. And at that moment, we are really going to have our reversed number. So 321, that is reverse number from the one that our user has initially entered. So let's now translate this algorithm into our code. So the loop that we are going to use in order to solve this problem here is going to be while loop. So I'm going to write while, and then in these parentheses here, I'm going to really give it an expression that is going to check each time that it wants to run an iteration. And what we are going to iterate through are the digits of this number here, so the number that our user has entered. So I'm going to say, please iterate through this part here, so execute this block of code here, which is currently empty, while our number, so number, where is it, is different than 0, like this. Okay. And inside here, we are going to write out the algorithm that I just explained. And the first step of that algorithm was really multiplying our reversed number by 10. So I'm going to say reversed number is equal to reversed number times 10, like this. Okay, and the shorter way to write this expression here is going to be like this. So you can really take this part here, delete it, and say it like this. It is going to do absolutely the same thing. So it is going to really multiply our reversed number by 10, and then whatever that results in, it is going to assign that back to our reversed number. So that was the first step. The second step in order to reverse our number is going to be really to take the last digit of this number that our user has entered. So how can we do that? We can do that by modulating this number here by 10. So I'm going to declare a variable. Let's call it last digit, like this. And as we already said, we can get that last digit if we modulate this number here. Where is it? So this number that our user has entered by 10, okay. That is going to give us the last digit of this number here. And then what we really want to do is we really want to add that last digit to our reversed number. That was one part of this algorithm, so the next step. So I'm going to say reversed number plus equal to last digit, like this. Or you can write it a longer way, but this way I prefer to write it this way. But you can as well say reverse number is equal to reverse number plus last digit. And after we have added that last digit to our reverse number, there is one more step left to do, and that is to really take that last digit from our number. And how we can do that? Well, we can really do that by dividing our number by 10. So you can say number is equal to number divided by 10, or number divided equal to 10, whichever way you prefer. Okay, so this is really the algorithm that we explained, and this step here you can really write out the shorter way if you want. So you can say, for example, reverse number plus equal to number modulated by 10, like this. So you can make your code a bit more readable if you prefer it this way, or you can leave this part here and then really add your last digit to your reversed number. So now that we have done this algorithm here, let's write out our reversed number and see what we have done. So I'm going to write out cout, and I'm going to say reversed, like this, okay. And I'm going to write out our reversed number. Okay, let me delete these empty spaces, and if I run my program now, it asks us to enter a number. So let's enter number 123, and now if I press enter, you can see that our program has really reversed this number here. So let's quickly one more time explain how this has happened. So our while loop has really iterated through this number here, so that in each iteration it is going to do the following. So it is going to take our reverse number, and initially that reverse number is equal to 0, so it is going to multiply that by 10, so it stays 0, and after that is going to take that reverse number and add it the last digit of our number that our user has entered. So that is going to be in a first iteration number 3, so our reverse number in that case becomes 3, so 0 plus 3 is equal to 3, and after that we are going to really take that last digit from our number that our user has entered. So it has taken this 3 part away, and then in the second iteration that's coming here, it is going to check again whether our number is not equal to 0, and our number is going to be 12 in that situation, so that is not equal to 0. So it enters here again. It executes this block of code here. So it says again, please multiply my reverse number by 10 and assign that again to my reverse number. So our reverse number was 3, and if you multiply by 10, if you multiply 3 by 10, you're going to get 30. After that, it is taking the last digit of the number that our user has entered, which is 2 now, because 3 we have taken away in our previous iteration. So it is going to add that 2 to my reversed number. So reverse number is going to become 32 now. And then it is really going to take that last digit from our number away. It is going to divide it by 10. So now we are left with number 1, and our reverse number is equal to 32. And then it goes back to our third iteration. It checks again whether our number, so whether our remaining number is equal to 0, and this 1 here is the value of our number, so that is not equal to 0, so this condition here is fulfilled. It can enter the while loop. So it does this algorithm here again. So it says, please multiply my reverse number by 10. Our reverse number at this point is 32. So when you multiply that by 10, you get 320. And then after that, it takes the last digit of our number, which is going to be this one. So this one here, which is the last one remaining. So it is going to take this one and add it to my reversed number, as you can see here. And then it is really going to take that last digit away. So it is going to take all of these 3 digits away. So it has taken them in the previous iterations, and now it has taken this one away as well. So our number is equal to 0 now. And then it goes back to our 4th iteration. It checks whether our number is not equal to 0, but in this iteration our number is equal to 0. So it really leaves this loop here. So it is not going to enter in this loop anymore, and then it goes here and it really writes out the value of our reversed number, which is this line of code here. So that is how we have reversed our number. So I hope that you like this video and that you understand this explanation. If you have any questions, write those in the comments down below, and also share this video with all your friends, with anyone who would like to learn programming. And thanks for watching. I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. If you are already a subscriber, welcome back. And if you're a new viewer, make sure to subscribe, hit that bell icon as well, and welcome to my channel. So in this video, I want to talk about the while loop. And in my previous videos, we have already talked about while loop and iteration in general. So if you are not familiar with those, make sure to watch that video. I'm going to link it here. But in this video, I want to explain to you how and when is used do while loop. And I'm going to give you an example of a program that is usually used. And for example, applications such as when you try to unlock your phone and then you are given 3 attempts to guess your PIN. And if you guess it correctly, then you can proceed loading your phone's applications further. Or for example, if you want to unlock your credit card, so you put your credit card in ATM and then it gives you 3 attempts to unlock your credit card. If you guess your PIN correctly, you can proceed further. But if you fail, so if you don't guess your PIN correctly in those 3 attempts, your account gets blocked. So that is the application that we are going to make today. And for that, we are going to use do while loop. So there are 3 things that we need, actually 3 variables. So I'm going to declare those 3 here. The first one is going to be our, let's say, the PIN of our user. So let's call it user's PIN, like this, which is going to be really the correct PIN, the one that you want to guess. So I'm going to put here, let's say 1, 2, 3, 4. That is going to be our user's PIN. After that, we need another variable, which is going to be really the PIN that our user enters. So let's call that variable just PIN. Okay, like this. And then the third variable that we need is going to be really counter of our errors. So the counter of the attempts and errors that our user has made. So I'm going to call that variable error counter, like this, and let's set that value initially to 0. Okay, and the next thing that we need to do is we really need to give our user 3 attempts in order to guess this PIN here. And if he guesses it correctly in those 3 attempts, we are going to write out that the application can be loaded further. So we are going to write out application is loading or something like that. But in the case that our user does not guess this PIN here, so this PIN here correctly, we are going to really write out that the application or credit card, whatever, has been blocked. And how we are going to do that? So we are going to use do while loop. So I'm going to write out do, like this. And then here I'm going to put while, because that is the syntax of our do while loop. Okay, and here you need semicolon, because if you don't put it, you are going to get a syntactic error. Now here we put the block of code that we want to execute in each iteration, and here we put the condition that we want to check each time that this code here is executed. We come here and then we check that condition, and if this condition here that we put is correct, we are going to go again here and do one more iteration, and then again check, and then do one more iteration, and we are going to repeat that until this condition that we put here is no longer true. When this condition here, when it becomes false, we are going to leave our do while loop. Okay, so what do we want to enter? So what do we want actually to do in this block of code here? We really want to write out a message to our user so that he knows that he should enter a pin, and then we want to really accept that pin that our user enters in this variable here. So let's do that first. I'm going to write out cout like this, and then let's just write out pin like this. And let's accept the value that our user has entered in our pin variable like this. Okay. And then after we have done this, what we need to do is we really need to check whether this pin here, so this pin that our user has entered, corresponds to this pin here. So whether this value is equal to this value here. And if they are not, that means that our user has failed. So in that case, we are going to increase our errors counter. So I'm going to put here if pin is not equal to user's pin like this. What we want to do is we want to really increase our errors counter variable like this. Okay, and this code here, so we want to give the attempt to our user so that he can enter a pin, and then we want to check whether that pin is correct 3 times, or until this pin here and this pin here are the same. So until they are equal, or until our user has used all of these 3 attempts that we have given to him. Okay, so here I'm going to really put that condition. So here inside these parentheses, I'm going to write out, please do this block of code here while our, let's say, while our errors counter is less than 3, like this, and then also at the same time while our pin is not equal to user's pin, like this, which means that this block of code here is going to be executed while our user has not used all of these 3 attempts that we have given to him, and while this pin here, so this pin here and this pin here are not equal. In a situation where this here results as false, we are going to come here, and after that, when we come here, we really want to check whether we have left this do while loop here because our errors counter has reached 3, or because these 2 were the same. In a situation where our errors counter has reached 3, that means that our user has used 3 attempts and that he has not guessed his pin correctly. So I'm going to put here if our errors counter is less than 3, like this, and this condition here really means that this do while loop has been left in a situation where our user has not used all of these 3 attempts that we have given to him. That means that this while condition has really failed on this part here. So that means that our user has entered 1, 2, 3, 4 as pin, and in that situation 1, 2, 3, 4 is not equal to 1, 2, 3, 4. That results as false. So this whole expression here, this whole condition results in false, and then we leave our do while loop. And in that situation, if our user has not used all of these 3 attempts, that really means that he has guessed his pin correctly. So here in this if situation, we can write out to our user, cout, you have guessed, or you can proceed with loading of this application. So I'm going to write out just loading, like this. But in a situation where our while loop has been left because this errors counter is greater than 3, actually it is going to be equal to 3, that means that our user has failed in guessing his pin 3 times, and that means probably that he's not trying to unlock his phone or his credit card. So in that situation, we are really going to block that account. So we can say else cout blocked, like this. Okay, And I'm going to put one more here, like this. So this is going to be a program that we really use to allow our user to enter 3 attempts of his PIN, and in a situation where he guesses that PIN correctly in those 3 attempts, we are going to write out to our user that he has successfully unlocked his phone, for example, and we can proceed with the loading of applications. But in a situation where he really uses all of those 3 attempts and fails to guess his PIN, we can write out that the application is blocked. Oh, blocked. Now it's okay. So let me run this program, and let's try to use 3 attempts. So I'm going to say that my first attempt is going to be, for example, 1111, like this. So it says you have not guessed correctly, please enter your PIN again. This is what it means. After that, I'm going to try, for example, 2222. It tries to prompt me to enter my PIN again because I have failed previously. And let's say that my third attempt is going to be 3333, like this. And then it has written out a message that my account has been blocked because I have missed 3 times. Okay, so that is one scenario, and the other scenario is going to be really where we guess, the one where we guess our PIN correctly. So let's say that our first attempt is going to be 1111 again, and after that we really remember what is the correct PIN, and we enter 1234, like this. And then if I press enter, it says really you are loading, you can load your application now, or the further loading of your application is going to begin now, because we have guessed the correct PIN. So let me very quickly explain one more time how has this happened. So this code here, when we come to this do while loop, the first thing that is executed is this line here. So it says please enter your PIN, and then after your user enters the PIN, your program really checks whether that PIN is equal to user's PIN, so the previous PIN, the one that he needs to guess. And if those 2 are not equal, that means that your user has not guessed correctly, and then you want to increase your errors counter, so the number of attempts that your user has used and failed actually in using. So we increase in our first iteration that errors counter to 1, so from 0 to 1, and then we come here, and then our loop really checks whether that errors counter is less than 3, so 1 is less than 3, that is true. And also it checks whether that PIN here is not equal to the PIN that we need to guess. And in this situation, it is not equal. So it also, this whole expression results as true, and it now can go here again. So it prompts you again to enter the PIN. So you can enter the PIN now. And in this situation, we entered 2222, for example. And then it guesses, it checks again. So it checks whether PIN that you have entered, so 2222, is not equal to 1234. Those 2 are not equal, so it increases the errors counter once more, and it becomes 2 now. Then you go here, and then it says, okay, please check whether my user has used all of these 3 attempts. It says that your errors counter is still less than 3, so you have used only 2 attempts so far. And then this condition here results as true because you have entered 2222, and that is not equal to your PIN, so 1234. And then it goes back here, tries to prompt you one more time to enter your PIN. And then if you fail this time, it increases your errors counter to 3, like this. And then it goes here and it checks whether your errors counter is less than 3. Your errors counter in this iteration has become 3, so this condition here results as false, and your do while loop actually is now broken. So you are not going to continue the execution of your do while loop, but you come here, and then it checks whether errors counter is less than 3 because this here fails, because this here results as false. You are presented with this message here, so blocked. Your phone, your account has been blocked. Okay, and in a situation where your user guesses correctly, that errors counter is going to be less than 3, and you are going to be presented with a message of loading. And there is one important thing that I want to mention, and that is really the difference between while loop and do-while loop. In do-while loop, you first do, so you first execute this block of code here, and then you check the condition. And then if that condition results as true, you go back and you again do this block of code here. And then you check, and then you do. But in a situation of while loop, you first check the condition, and then if that condition results as true, then you can really proceed with executing your block of code that comes after your while. But in this situation here, so in the situation of do while loop, you first do this block of code here. So irrelevant whether this condition here is true or not, you are going to do this block of code here at least once. I hope that you liked this video. If you did, make sure to subscribe to my channel and click that bell icon as well. And also, if you want me to post more videos like this, make sure to like this video, because then I will know that you liked it. And, well, that's all. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video, I want to talk about for loops, but before we start, make sure to subscribe to my channel and hit that bell icon as well. Okay, so what I'm going to explain today, I want to explain to you how for loop works, and I'm going to explain that on a simple example, which is calculating the factorial of a number. So let me copy the text of our task here, like this, and I'm going to comment it out. So what is the factorial of a number? Factorial of a number is usually defined as a product of all numbers between 1 and that number that you want to calculate the factorial of. That means, for example, if your user enters number 6, let's say, and you want to calculate the factorial of number 6, you are going to do that in a following way. So 1 multiplied by 2, multiplied by 3, 4, 5, and 6, okay? And then this here is going to result in 720, so this 720 is really going to be the result of your factorial of 6. And this example here is what we want to really translate in our program. So we want our user to enter a number, and then we want to calculate the factorial of that number and write that result out to our user. And we are going to use for loop for that. So let me quickly declare a variable which is going to be called number, okay, like this. And let's prompt our user that he should enter a number. And then let's really store that number that our user enters in our number variable. Okay, so after we have acquired a number that we want to calculate our factorial of, let's explain how we are going to really do that. So I'm going to do that using for loop. And what is the difference between for loop and while loop and do while loop? Because we have previously talked about while loop and do while loop as well. You can find those videos on my channel if you're interested, and I'm going to link those videos in the description of this video if you want to watch them. So the difference is that usually when you use for loop, beforehand you should know how many iterations that loop is going to make. So for how long your loop is going to run. So let me show you the syntax of our for loop. You say for, and then you use these parentheses here in which we are going to put certain expressions in a moment. And after that you put these curly brackets in which we are going to write out the code that is going to be executed in each iteration of our for loop. So inside these parentheses here, we need to put 3 things. What are those 3 things? The first one is going to be to set the initial value of our counter variable. That is the first one. After that, the second is going to be to really put the condition that your for loop is going to check each time that it wants to run this block of code here. So before each iteration, it is going to check that condition. So that is going to be the second thing. And after that, the third thing is going to be really a way for your counter value to come to that condition, which means that you have to either increase or decrease your counter variable in order to reach that condition at certain point, and then when that condition results as false, your for loop is not going to be executed anymore. Okay, so those are three things that we need to put in these parentheses here. And let's now look at this example here, because from here we are going to really deduct which conditions, which expressions we are going to put here. So if you notice this algorithm here, because this is really algorithm, nothing else, you see that this is really a counter. This behaves as counter. So it goes 1, 2, 3, 4, and it really starts at 1, and then it goes up to that value that your user has entered. So we can use that for our expression here. The first expression is initial value of our counter. We need to declare that variable, and we are going to call that variable I. You can call it counter or whatever you want. Really, your compiler is not going to give you an error because of that, but the common practice is to use a single letter variable name for this counter that you use in your for loop. So I'm going to use name I for that, and the initial value of my I counter is going to be 1, because as you can see here, it really starts on 1, and then after that we need to put the condition that your for loop is going to check each time that it wants to run a new iteration. And that condition, as you can see here, is really this expression here. This algorithm runs until it comes to this 6, until it comes to the value that your user has entered. So we are going to put that here. We are going to say, please run this block of code here until my I is less or equal to number, like this, so whichever number our user enters. And then the third thing is going to be really to give our loop a way to reach this condition here at some point, which means to make this condition here false and then leave our for loop. And again, we look here and you can see that your counter is really increasing in each iteration by 1. Okay, so here we are going to put I plus plus, which is in each iteration going to increase the value of our I counter by 1. Okay, so after we have put these expressions in these parentheses of our for loop, we need to really put a block of code that is going to be executed in each iteration of our for loop. And I'm going to declare, before this for loop here, I'm going to declare another variable, which I'm going to call factorial, and I'm going to give it a type of int. Okay, like this. And I'm going to assign the initial value to my factorial variable, and that is going to be 1. And then how I'm going to use this factorial variable. In each iteration of my for loop, I want to say that my factorial is going to be equal to whatever my factorial was previously holding, multiply that by my current I value, which means by the current value of my counter. And how this is going to behave. So let's say that our user enters, for example, number 3, and then your execution comes here and it says, please declare a variable which is going to be called factorial, and it is going to have a value of 1. So we have assigned that value here, and then it comes to your for loop. The first thing that your for loop is going to do is it is going to declare this I variable here and assign it a value of 1. So we are going to write that here. So we are going to say I is equal to 1. And then it really goes here and checks this condition here before it determines whether it's going to run this block of code here or not. So if this here results as true, it is going to run this block of code here, and if not, it is going to leave your for loop. So is your I less or equal to the number that your user has entered? So your I is going to be 1, and then that is less or equal to 3. So your for loop is going to execute this block of code here, which means that it is going to come here and say factorial multiplied by 1, which is going to be 1 multiplied by 1, and that is going to result as 1. And it is going to assign the result of this here to your factorial variable, which is going to stay 1. After that, your for loop comes here, and at this close bracket here, it really goes here, and it increases the value of your I. And this increment operator is going to increase it by 1, so your I now becomes 2. And then after that, it goes back here and checks this condition here. So it says, please check whether my 2 is less or equal to the number that your user has entered. So 2 is less or equal to 3. So it is going to run this block of code here again, and then it is going to do following. So it is going to say, please multiply my factorial value, so the previous value that my factorial was holding, which is 1, by the current value of my I, which is 1 multiplied by 2. That is going to result as 2, and that is going to be assigned to your factorial variable. So we assign 2 here, okay? And then it goes back to these close brackets, and then it goes here, increases the value of your I again, so your I now is 3, and then it really checks this condition here, so whether 3 is less or equal to 3, the result of that is going to be yes. So it is going to do this expression here again. So the current value of your factorial, which is going to be 2, multiplied by the current value of your counter variable, which is going to be 3, so 2 multiplied by 3, that is going to be 6, and that is going to be assigned to your factorial variable. After that, it goes here, and then it really increases again the value of your I variable, so of the counter that you are using in your for loop, and that value becomes 4 now. After that, it is going to try to check this expression here, so this condition here, and 4 is not less or equal to 3, so your for loop is not going to execute anymore, and then your execution comes here, and at this line of code here, it has the value of 6 in your factorial variable, which means that we are left only with the need to write out this to our user. So we need to say, let's say it like this, number, okay, and then let's say factorial of that number is going to be equal to, and then let's write out the result. So the result we are holding in our factorial variable like this. So this should really write out the result of this here. So the factorial of this number that our user has entered. And if I run my program, you can see that it asks us to enter a number. I'm going to say, let's say for example 3. And then if I press enter, it is going to give us the result of 6, which is the correct result, the one that we previously got. Let's run it one more time, just to check this number here. So I'm going to say, please give me a factorial of 6, and it calculates that the factorial of 6 is 720, as we did before. So this is going to be really one way of writing this for loop for this current example. So for calculating factorial. I want to show you another way how you can do exactly the same thing. So I'm going to really comment this part of code here. So I'm going to say comment this block of code here. And then there is another way to write these parentheses here. So as you can see, this example here is what we have used in order to write these expressions inside these parentheses. But there is really one more way to calculate your factorial, and that is going to be to start at this maximum value, which means 6 factorial is equal to 6 multiplied by 5, by 4, 3, 2, 1, and that is going to be equal to 720. So now you start your counter at this maximum value, so this number that your user has entered, and then you really decrease the value of your counter and you go until your counter value comes to 1, and that is the condition when you stop. So your 1 value of a counter is going to be the last iteration through your for loop. So now we are going to write out, so actually we are going to really write our for loop using this algorithm here. So we are going to say for, and then also put these parentheses, which we are going to use for the block of code that we want to run through in each iteration. And in these parentheses here, I'm going to set the initial value of my counter. That is going to be I is equal to, and as you can see here, our I starts at 6. So I'm going to put here 6, which means a number that our user has entered. In this current situation, it is 6. But since we want to calculate the factorial of whichever number our user decides to enter, I'm going to use that variable here. Okay, and then the condition that your for loop is going to check each time that it wants to make a new iteration, and that is going to be, please run this block of code here until my I is greater than or equal to 1. Okay, and then the last thing that we need to put here is going to be really a way for our for loop to stop at a certain point. And if you look at this example here, you see that your counter is decreasing by 1 in each iteration. So we are going to put that here. We are going to say I minus minus, which means use this decrement operator on our I variable. And then we are going to really use the same expression here. Okay. And this is going to give us the exactly the same result as this code here did. So if I run my program, you can see that it asks number again. So if I enter number 6, for example, it is going to give us 720, as this code here did as well. So let's repeat one more time. There are 3 things that you need to put in these parentheses here in order to set up your for loop. And the first one of those 3 is going to be to set the initial value of your I variable, which means the initial value of your counter. After that, you need to put the condition, which is going to be checked each time that your for loop wants to run an iteration. And if this condition here results as true, your for loop is going to run this block of code here. But if this condition here results as false, your for loop is not going to run this block of code here, but you are really going to leave your for loop and come to the next line after it. And then the third thing that you need to put in these parentheses here is going to be really to either increase or decrease value of your counter variable so that it can reach this condition here at certain point and make it false. So we have decreased it in this example here, and we have increased it in this example here. So those are 3 things that you need to put inside these parentheses here, and you really need to separate those 3 using this semicolon sign. Okay, and there's one more thing that I need to mention, and that is going to be really, you can upgrade this program here so that it checks whether this number here is greater than 0, because you cannot calculate factorial of negative numbers, so our program is not going to behave as expected if you enter negative number, and also the factorial of 0 is going to be equal to 1. So you can put that code here and determine whether your user has entered positive or negative number. And in case that your user has entered negative number, make sure to write out appropriate message to your user. So I think that is all. If you like this video and if you learned something new, make sure to subscribe to my channel and hit that bell icon as well. Share it on your social media because it really helps me to reach a lot more people so that all of us can learn and upgrade our knowledge in programming. And I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video, I want to talk about nesting loops. In my previous videos, we have talked about while loop, do while loop, and for loop. And now I want to show you the example on how you can really combine and nest those loops. So if you haven't watched my previous videos or you're not familiar with loops at all, I recommend you to watch those. I'm going to link those in the description of this video. And also, before we start, make sure to subscribe to my channel and click that bell icon as well. So what are we going to do in this video. I want to really show you how you can nest for loop and do while loop, and the example that I'm going to use to explain that is going to be following. So I want my user, which is going to be a student, let's say, to enter 3 grades or more. If you want, we are going to use 3 for this example. And I want those grades to be between 1 and 5. And then I want to write out the average grade. So the average grade between those 3 that he has entered. So let's start building our program. The first thing that I need to explain is, since we are going to enter 3 grades, that means that we are going to repeat that entering process 3 times. And for that, I'm going to use for loop. So I'm going to write for, and then in these parentheses here, I'm going to put my initial setup of for loop, which is going to be, the first thing is going to be initial value of our counter. So I'm going to declare a counter, which is going to be called I, and initially I'm going to give it a value of 0. That is the first thing. The second thing that I need to put in these parentheses here is going to be the condition that our loop checks each time that it wants to run a block of code, which is going to be this block of code that we put inside these parentheses. So that condition we put here, and that condition is going to be while our I is less than 3. So we want to make 3 iterations. In the first iteration, our I has the value of 0. In the second iteration, it's going to have the value of 1. And then in our third iteration, it's going to have the value of 2. So we have made 3 iterations. After that, it gets the value of 3, but this condition here is not going to be true anymore. So then our for loop is not going to be executed anymore. So that is the second thing. And then the third thing which we need is going to be really increasing that value of our counter in each iteration, so after each iteration. And I'm going to put here this increment on our I variable. Okay, so in this block of code here, we are going to repeat 3 times something. So what is that something? That is going to be really the process of our user entering the value for his grade. And since we said that that grade needs to be between 1 and 5, I am going to use do while loop for that. How? Well, I'm going to write out do, okay, and then here I'm going to put while, which is going to be the condition. So here we prompt our user to enter the grade, and then we say here, you are going to have to enter that grade while that grade is less than 1 or greater than 5. So since we don't have any variable that we are going to use to enter that grade, I will have to declare it here. So I'm going to say here int grade, like this. Okay, and then let's prompt our user in this block here to enter his grade. So I'm going to write out cout, and let's say enter grade, and I am going to use the current value of my counter so that I can really say which grade my user is entering. So enter first grade, second grade, and third grade. So I'm going to say I plus 1, like this. Why plus 1? Well, because our counter starts at 0, and it wouldn't make much sense to say to our user, please enter grade 0. So that is why I'm increasing this value of my I when I want to write out a message to my user. Okay, like this. So here I'm going to write out please enter a grade, and after that I need to accept that grade that my user enters in my grade variable. So I'm going to say cin grade, like this. And we are going to repeat this process here for a single grade while our user enters a grade that is less than 1 or grade is greater than 5. Okay, so our program is really going to prompt our user, please enter grade 1, and then he enters 6, for example, and then our program checks this condition here and says, okay, you have missed this part here, so go back, and then please enter grade 1, so first grade again. Okay, so if I run my program now, let's just prove that very quickly. So our program says now enter first grade, so enter grade 1, and then let's say that I enter 9, for example. It prompts me again to enter first grade because I have not obeyed this rule here, this part here. So I'm going to say this time, for example, 5, and then it says, okay, you have successfully entered first grade. Let's now enter second grade. So for that second grade, let's enter, for example, 0. And then it prompts me again, you have not entered correct value for grade 2. Please enter it again. And let's say that this time I'm going to enter 1. And then it asks for third grade. And let's say that this time third grade is going to be 3. So our program now has successfully accepted this third grade, and now our program is going to really finish its execution because we haven't written anything else after this part here. So there is something else that we need to write, and since we want to calculate the average grade of our user, what we are going to need is going to be really to sum all of these grades that our user enters. So I am going to declare a variable which is going to really hold that sum of our user's grades. So I am going to put it here. I'm going to call it sum, and initially I'm going to assign it a value of 0, and later I'm going to explain why. So I have declared a variable that is going to be of type int, and I have called it sum and assigned it a value of 0. So this sum here is going to, each time that our user enters a grade, and we really check that that grade is valid grade. After that, we want our sum to hold whatever it was previously holding plus the value of our grade, like this. Okay. So why I have assigned a value of 0 to my sum? Because 0 is a neutral value when it comes to adding numbers. You add 0 to whichever number and then you get that same number. And in a situation where we didn't assign any value to our sum, we would get really an error. So if I try to run my program now, you see that it prompts me with an error and it says uninitialized local variable sum used, because it does not have any value assigned to this variable here. It is going to say really that it does not know how to add the value, so the value of our grade, to our sum. So that is why we need to assign some value to our sum variable. Okay, so and that value is going to be 0 because 0 is neutral when it comes to adding numbers. Okay, so now I can really run my program, and as you can see, that error has disappeared. So I'm going to stop my program, and let's very quickly write out this sum that we have calculated here. So I'm going to say cout, and I'm going to write out sum like this. Sum is equal to, and then let's write out the value of our sum, and let's add end line like this. So I am going to run my program once more. It prompts me to enter first grade. I'm going to say that my first grade is going to be, for example, 5, and then my second grade is going to be, for example, 6. That's an error, so please enter your second grade again. So I'm going to enter this time 2, let's say, and then for my third grade, let's enter 1, for example. And it says that the sum of my grades is equal to 8, which is correct. So 1 plus 2 plus 5, that is going to equal to 8. So what we are left to do, now we should only really divide our sum by the count of our grades, which is 3, because we have hard-coded this value here to 3. So our user can enter only 3 grades. You can really use a variable for this, or you can hard-code it to any other value that you want and need. So here, after this line of code here, what I need to do is following. So I'm going to say cout, and then let's say average is equal to, let's say average grade is equal to, and let's write out the result. So that is going to be sum divided by 3. Okay, is it though? So I'm going to run my program, and let's enter, for example, value 2, and then again value 2, and then let's enter, for example, value 4, and then it says that average grade is equal to 2, which is not correct. But why has this happened? So as you can see here, we have used two integer variables. So our sum is integer value, and then 3 is integer value as well. So when you divide two integer values, the result is also going to be integer value. So in order to get a floating point, a decimal point number, you really need to convert one of these two into a float type. So you can say either here, you can say float. So please convert my sum variable into float and then divide, or you can put here this 0.0, or you can leave both of these, whichever you prefer. So I'm going to leave both of these like this. So if I run my program once more, it prompts me again to enter first grade. So I'm going to say that my first grade is equal to 5, and then my second grade is also 5. And then let's say that the third grade of our user is going to be 9. So our program prompts us again to enter the third grade because it needs to be in this interval here. So I'm going to say now that the value of my third grade is going to be 3, which is correct value. And after that, as you can see, it writes out that the sum of these 3 grades is 13, and then average grade is 4.33333. So that was an example on how you can really combine and nest loops in order to solve complex problems. And thanks for watching. Make sure to subscribe to my channel, click the bell icon, also share it with anyone who would like to learn programming, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video I want to talk about nesting for loops. So I want to show you how you can solve more complex problems using nested for loop. But before we start, please subscribe to my channel and click the bell icon as well, and also like this video. So this example that we are going to do today is going to be really multiplications table. So I'm going to show you the example that I want to program. So that would be this here. And if you look at this multiplication table that we want to make, you can really start to notice a pattern. And what pattern I mean? You see here, this first operand in this first part of my multiplication table, so in this first table, as you can see, this first operand is 1, and it stays 1 in this table here. After that, you can look at this second table, you see that this operand is now 2, and then in my third table it has increased to 3, 4, 5, and it really increases, so it increments by 1, and it goes up to 10. Okay, so that is the first operand, so this first part of my multiplication. After that, we can look at this second operand, and you can really notice that it increases in each iteration by 1. So it goes 1, 2, 3, 4, 5, up to 10. And then it does the same thing in this second table. So it goes from 1 to 10 again. And then the same in my third table, fourth, fifth. And it really behaves the same in this 10th table as well. So that is the pattern that I want you to notice. So this first operand can be really represented using one for loop. So let's say that that is going to be outer for loop. And it is going to increase each time that my second operand counts from 1 to 10. And that second operand we can really represent using another for loop, which is going to be really inner for loop. So the program, the algorithm for solving this problem is going to go like this. You have outer for loop, which is going to count from 1, 2, 3, 4, up to 10. So it is going to count from 1 to 10. And then you are going to have inner for loop, which is also going to count from 1 to 10. But for each value of my counter of my outer loop. Okay, so that means that my outer loop counter changes only after my inner loop has counted from 1 to 10. So let's copy the text of our task here. I'm going to say multiplication table, and let's comment that text out. So as we said, in order to solve this problem, we are going to use nested for loops. So I'm going to add empty space here. And then the first thing that I need is going to be my outer loop. So I'm going to really set up my outer loop. I'm going to say for, and then we need to declare a counter, which I'm going to call I. So I'm going to say int I is equal to, and then since our outer, let me show you this image one more time, since it goes from 1 to 10, I'm really going to set its initial value to 1. So I'm going to say I is equal to 1, and then I'm going to write the condition, so how long this for loop is going to run, and that is going to be while this I is less than or equal to 10, like this, and then each iteration it is going to increase by 1, so that is going to be I plus plus. Okay, and then I'm going to put this block of code here that is going to be executed in each iteration of this for loop. So what we need to do in each iteration of our for loop, let's look at our image one more time, and as you can see, it really says that in each iteration of this outer for loop, you need to count from 1 to 10. So in this iteration here, some other counter really counts from 1 to 10, and then new iteration, so our I is now 2, and then counter counts again from 1 to 10, and then 3, but also we have this inner counter that counts from 1 to 10. Okay, so let's really write that code. So that inner counter that counts from 1 to 10 for each value of our I, we are going to represent with another for loop. And that is going to be really that nested or that inner for loop. So I'm going to write for. And that inner counter I'm going to call j. So I'm going to write int j. And since our j also counts from 1 to 10, I'm going to set its initial value to 1. And I'm also going to say, please iterate through this for loop while our j is less than or equal to 10 as well. And then in each iteration, please increase the value of j by 1. So do this increment operation. And then in each iteration of our j loop, we are going to execute this block of code here. So what we are going to do in this block of code here? Well, let me look at that image once more. And as you can see, in each iteration of our j, so this is one iteration of our j, this is second, third, fourth, fifth, and then 10th iteration of our j. After that, we change our I counter value, so we increment that, and then our j starts one more to count from 1 to 10. So in each of these iterations, as you can see, really we have to multiply our I value counter with our j value counter and write the result of that. So I am going to write that here. I am going to write cout like this, and then let's write out the value of our I counter like this, and then let's write out this multiplication operation, and then let's write out j like this. This is just formatting our text, so I'm going to put this equal sign, and then I really want to multiply those two counters like this. And let's also add one end line here so that our text is formatted nicely, because we are going to have multiple lines. So with this, we have really covered this multiplication part. And there is only one more thing left to do, and that is to add one more end line, because I really want to make separation between these. So I want to make separation between these tables. This is going to be one logical part. After that, this is going to be another, then third, fourth, and I want to put empty space between those two so that I can group them. So I'm going to add here cout end line like this, and that should be it pretty much. So if I run my program now, as you can see, it has generated this multiplication table from 1 to 10. Okay, and it has done that in a matter of less than a second. So as you can see here, we have this outer counter. Oh, I cannot mark that only. So we have this outer counter, which is going to be our I, that counts from 1 to 10. But for each value of our outer counter, for each value of our I, we have to really count from 1 to 10 with our inner counter, which is going to be our J, as you can see here. Okay, so these are the results of our multiplication operation. And I hope that you have seen now how you can really use programming to your advantage, how you can use it to solve not really complex, but tedious tasks. You would really need 20 or 30 minutes in order to write this yourself, and you can now generate it with just a couple of lines of code and less than a second of your computer's power to really execute this code here that you have written. And the most amazing part is that you don't really have to put 10 here. So we have put 10 here because I want to make this example manageable for this video, but you don't have to hard code these values here. You can really use whatever values you want. You can say, for example, let's say 2000. Okay, so I want to generate multiplications table up to 2000. How long would that take in real life? So without programming. Okay, now you see.
A few moments later.
Okay, so it is still running and it is going to generate around 4 million records, which is a lot, and it is going to do that in a matter of minutes. So how long would it take for you to even just count from 1 to 4 million? It would take you probably days, if not months. And also there were a lot of errors that you would probably make in that process. So I hope that now you can really recognize the power of programming. Now, if you needed to do this task, you would really program your computer to do it, and now you can just go take a break and your computer is going to finish that task for you. So I hope that you can recognize now how you can use programming in order to solve different types of tasks that you can come across in your school, in your job, or life in general. And if you like this video, make sure to subscribe to my channel. Also click the bell icon and share it with anyone who would like to learn programming. And I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. In this video, I want to show you how you can draw shapes using C++. So before we start, make sure to subscribe to my channel and also hit that bell icon as well, so that you are notified when I publish my next video. And let me show you now what we are going to do in this video. So here, where is it? Here I have image of the task that we are going to do today, and that is going to be really to draw this rectangle shape with the desired height and width and a symbol that our user enters. Okay, so that is the task that we are going to do in this video. And let's very quickly analyze this problem and see how we are going to solve it. So the first thing that we need is for our user to enter height, width, and then symbol. And after that, we will really need to figure out a way, so figure out the algorithm on how we are going to draw this rectangle shape here. So if you look at this rectangle shape, you can really notice that it has the height that is going to be 3 of these symbols that our user has entered. And then it has the width that is going to take 4 of these symbols that our user has entered for width. Okay, so we are going to use nested for loop in order to solve this problem here. And if you're not familiar with nested for loop, I am going to link that video here because I have already made one video with nested for loops, so make sure to watch that video. And in this video, I am going to really use that nested for loop in order to control height and width of our rectangle shape. So we are going to have outer for loop, which is going to really control this height. And then for each iteration of our outer for loop, we are really going to control this width with another loop, and we are going to count from 1 up to 4, because 4 is the width that our user has entered, and draw that shape in each iteration of our inner for loop. Okay, so that is what we are going to do. So let's now translate that into code. I'm going to say here, first thing that we need is going to be from our user to enter width and height. So I'm going to declare two variables. The first one is going to be height, like this, and then width. Okay, so let's write out a message to our user so that he knows that he should enter height. Okay, now let's accept that height value in our height variable, and after that let's really copy this and do the same thing for our width, like this, and accept that value in our width variable. So that is the first step. The second step is going to be to declare another variable which is going to hold the symbol that our user wants to use for drawing that shape. So I'm going to declare a variable of type char, and I'm going to call it symbol, like this, and let's write out a message to the user so that he knows that he should enter that symbol, like this, and let's say cin symbol. So after we have acquired all the necessary inputs from our user, which are height, width, and symbol that we are going to use to draw our shape, now we are left to write the algorithm that is going to draw that rectangle shape. So as I already said, for that we are going to use nested for loop. So I am going to set up my outer loop, the first loop, and I'm going to say for, and then I'm going to declare the counter, which is going to count the iterations of my outer loop. Since that outer loop is going to control the height of our rectangle, I'm going to say int age, so I'm going to give the age name to our outer counter, and I'm going to set its initial value to 0, like this, and then we are going to put the condition how long our outer loop is going to run. So while our age is less than height that our user has entered, like this, and then after each iteration of my outer loop, we have to increment the value of our age counter. So that would be the setup of our outer loop. And let's now set up our inner loop. So I'm going to write for, and for this inner loop, I'm going to declare another counter, which I'm going to call w, like this, because this inner loop is going to control the width of rectangle shape, so I'm going to set its initial value to 0 as well. And then I'm going to say that it is going to run while this w is less than width that our user has entered, like this. And also after each iteration, we really need to increment the value of this w. Okay, so what we are going to do in this loop, so in this inner loop, if you look at this image here, where is it? Okay, here, you can really notice that in each iteration of our inner loop, it just draws this symbol that our user has entered. So I am going to very quickly just cout, so write that symbol out. I'm going to say cout, and then write out that symbol, like this. And there is really one more thing that we need to put, and that is going to be after this for loop. So this outer for loop finishes single iteration, we really need to put something else at the end. So here, at the end of our outer for loop. And let's look at our image. So as you can see here, after each iteration of our outer for loop, because it is controlling height and it is really iterating through this inner for loop in each iteration of our outer for loop, at the end of that iteration of outer for loop, we really need to put empty space. So here I need to put empty space, and that corresponds to this line here. So here I'm going to write out cout end line, like this. And now if I run my program, we should really expect to see the shape, that rectangle shape of dimensions that our user defines. So let's say for height 4, and then for width, let's say for example 6, and the symbol that we want to use to draw that shape, let's say that that is going to be this plus symbol. Okay, so as you can see, our rectangle has the height of 4, and then it has the width of 2, 4, 6. So it has the width of 6 of these symbols that our user has entered. Okay, so there is one more thing that I notice here, and that is going to be really to format this shape to be a bit more pretty. So for that, we are going to use the library, which is called iomanip. So I am going to include that library here. I have to say include iomanip like this. And this library here really contains a function that is called setW, which means set width, which is really going to set the width of the field that comes after it. So I'm going to put here that function. I'm going to put these redirection signs here, and then in this space here, I'm going to write out set v, so set w actually. And then here I want to put what is the width of the field that comes after this function. So what is going to be the width of our symbol field? And let's use 3 for that, for example. So if I run my program again, but let me stop it first. And if I run it again, oh no, I haven't stopped my program, so I'm going to close it. Okay, and now if I run my program, you can see that it asks height and width again. So previously we have entered 4 and 6, and then for the symbol, let's enter plus again. And now, as you can see, our shape looks much nicer because of this set width function, because it has really assigned to each symbol, to each character that our user has entered, the width of 3 fields. Okay, so let's run our program one more time, and let's say that height is going to be 5 and width is going to be 7, and let's enter another shape. So let's say, for example, minus, and as you can see, it has written out the shape, so the rectangle shape of these dimensions that our user has entered, and it has used this symbol that our user also has entered. So I hope that you enjoyed this video. If you did, make sure to subscribe to my channel and click the bell icon as well. Also, if you want me to make more videos like this, so if you want me to use programming to draw more shapes, make sure to write that in the comments down below so that I can know that you really enjoyed this video and like it as well. And thanks for watching. I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ for beginners. And this video is going to be sort of a continuation to my previous video in which I showed you how you can draw rectangle shape using C++. And in this video I want to show you how you can draw triangle and reversed triangle shapes using C++ as well. So if you're not familiar with how you can draw rectangle, I would suggest you to watch that video first. I'm going to link it here, because in my opinion it is a bit more difficult to draw triangle than it is to draw rectangle shapes. So one more thing, I have also created Instagram and Twitter accounts, so if you're interested in how developer life looks like, and also if you're interested in behind the scenes of these videos that I post on YouTube, make sure to follow me on my other social media. So at TrueCodeBeauty, Instagram and Twitter accounts, I'm going to put the link to those in the description of this video. So without further ado, let's start drawing our triangle shape. So here I have the shape that we are going to draw in this video, and that is going to be this equilateral triangle shape that I have here. And there is a couple of things that I want to explain before we start to write code. The first thing is going to be that this height, our user really has to enter this height. So we are going to let our user decide how many of these symbols are going to be on this side and this side and this side as well. And the second thing is going to be that our user defines this symbol. So whichever symbol our user wants to use in order to draw this shape, we are going to use that symbol that he enters. Those are two things that we need from our user. And then it is up to us to really think and figure out the algorithm that we are going to use in order to draw this triangle shape here. So let me explain to you how we are going to do that. So we are going to have two for loops, and those are going to be nested for loops. So if you're not familiar with for loop nesting, I'm going to link my video on that here, so make sure to watch it. So our outer for loop is the one that is going to control this height of a triangle. So in this particular case, it is going to have 5 iterations, 1, 2, 3, 4, 5. And then our inner for loop is the one that is going to control the width of this triangle. And if you really look at this triangle, you can notice that our outer for loop really goes from 1 up to the number that our user has entered. So it has 5 iterations in this particular case because our user has entered 5 for the length of this triangle, so for the length of its sides. So that is the behavior of our outer for loop. It goes from 1 up to 5 in this particular case. And then the behavior of our inner for loop is going to be the following. So in the first iteration of our outer for loop, our inner for loop has only 1 iteration. After that, in the second iteration of outer for loop, inner for loop has 2 iterations. Then in the third iteration of outer for loop, inner for loop has 3. In a fourth iteration of outer for loop, inner for loop has 4, and so on. So that means that our inner for loop goes from 1 up to the current value of the counter of outer for loop. So let's translate that into our C++ code. Let me return this picture here. Okay, so before we start to write that algorithm, I am going to create a variable which is going to hold the length that our user enters. So I'm going to call that variable length. Okay, and then let's write out a message to the user so that he knows that he should enter length like this. And let's store the value in our length variable. So that is the first thing that we need from our user. And then the second thing is going to be a symbol. So that is going to be of type char, like this. So I'm going to write out, cout symbol, like this, so that our user knows that he should enter symbol as well. And let's store that symbol in our symbol variable. So after we have acquired these two things from our user, let's translate the algorithm that I just explained into C++ code. So as I said, we are going to have two for loops. Outer for loop, which is going to have counter that I'm going to call, let's say, I. And that outer for loop, its counter goes from 1 up to the value that our user has entered, and it increases by 1 in each iteration. Okay, so I'm going to say I is equal to 1, and then I is less than or equal to length, so the length that our user has entered, and then please increment that I in each iteration. So that is going to be outer for loop, and then inner for loop is going to go from 1 up to the current value of outer for loop's counter. So in the first iteration, it is going to execute only once, so it is going to have only one iteration. In the second iteration of outer for loop, it is going to execute twice. In the third, it is going to execute 3 times, 4 times, 5 times. So how we are going to write that? We are going to say for int, and then our inner for loop's counter I'm going to call j, and j goes from 1 up to the value of our I, so up to the value of outer for loop's counter, and it increases by 1 as well in each iteration, and in each iteration it has to write out this symbol that our user has entered. So let's say cout symbol, like this. Okay, and then there is one more thing that I want to explain, and that is going to be after each iteration of outer for loop, really the next iteration starts in a new line. So we are going to write that here, I'm sorry. So at the end of our for loop, our outer for loop, we are going to say cout end line. Okay, and now if I run this program, it asks for length. I'm going to say that length is, let's say, 5, and then symbol is going to be star symbol. And as you can see, it has really written out a triangle that has the length 5 of these symbols that our user has entered. And there is one more thing that I want to do in order to format this shape here to be a bit prettier, and that is going to be really to add a function here which is going to assign to each of these symbols that our user enters, so that our for loop writes out, width of 2 fields. And that is going to be done using a function that is called setW, meaning set width. And this function here is going to give the space of 2 fields to the symbol that comes after it. And in order to use this function here, we have to include its library, and that is going to be iomanip library. So I'm going to say include, like this, iomanip. Oh, okay. And now this underline has went away. So if I run my program once more, and I enter, let's say, for length 6, and then for symbol, I enter this symbol here. As you can see, our triangle shape looks better now. So it has the height, or actually the length, of 6 of these symbols that our user has entered, and it has also used this symbol here in order to draw this triangle shape. And there is one more thing that I want to show you. So at the beginning of this video, I promised that I'm going to teach you how you can draw triangle shape and then reversed triangle shape as well. So there is one very beautiful thing about programming, and that is going to be code reusability. And about real code reusability, you are going to learn when we learn about classes and functions. And when I make my videos on functions, I'm going to link that video here, so make sure to watch it, because functions really are one of the most important things that you have to understand, not only for C++ programming, but for programming in general. So make sure to watch that video. And let's say that for now we are only going to really adjust this code here. So we are going to modify it a little bit in order to draw this shape here. So if you look at these two shapes, you can really notice similarities. And what are those? So this inner for loop behaves about the same in both of these triangles. But there is one key difference, and that is going to be that in this triangle shape, our outer for loop counts from 1 to 5, and then in this reverse triangle, our outer for loop really counts from 5 to 1. So if we modify that, we are going to have this reversed triangle. So let me move these, and then I'm going to really copy this here. So I'm going to use Control C and then Control V. And then let's really add a couple of end lines between these two. Okay, like this. And then let's really modify this triangle shape that we have just explained and drawn. And as you could see on this image here, our outer for loop counts from 5 to 1, which means from the size that our user has entered, from 1. So that means that if we change our outer for loop, we should get that reverse triangle shape. So it goes from length, like this, and it really goes while our I is greater than or equal to 1, and then our I decreases in each iteration, so it decrements. And now if I run my program, it asks me for length. Let's say that length is going to be 5, and then symbol is going to be, let's say, this plus symbol. And when I pressed enter, we have gotten both of these triangle shapes. So this one that we have drawn first, and then this reversed triangle shape as well. I hope that now you have really seen the real beauty of programming. You learn some basics, and then you can use those basics in the most creative ways that you can think of. So I hope that you liked this video. If you did, make sure to subscribe to my channel, click the bell icon as well, so that you are notified when I publish my next video, and a lot more great videos are coming. Thanks for watching. I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to the first video of C++ functions. If you're a beginner at C++, make sure to check out my playlist on C++ for beginners, and there you can find some of the most important concepts that you will need to understand and know in order to work with C++. And in this video we are going to talk about C++ functions. So functions are one of the most important concepts that you will need to understand and use in order to be a good programmer. And that is not only the case in C++, but in most programming languages as well. The first thing that I want to explain is what is function. Function is a block of code that is grouped together, and usually that block of code solves a specific problem, meaning it performs a specific task, and that block of code is executed only when you call that function, meaning only when you invoke the function, the body of that function is going to be executed. And each C++ program contains at least one function, and that is going to be main function. So this here, and the execution of your program starts on the first line of your main function, and then it ends when it comes to this last line, so this closed bracket of your main function. And also it can end when it comes to return statement, but we are going to talk about return statements later in this course. So main function is the main one, so the first one that is executed, and whatever code you put in your main function, that code is going to be executed as part of your program. So if I say here, for example, cout, and I say hello from main function like this, and let's add a new line like this, and now if I run my program, you can see that our program has written out hello from main, and that is the first function that our program starts executing. Besides from main function, you can also create your own functions, and let's explain how you can do that. So there are a couple of things that you need to know in order to create your own function, and that is going to be following. So the first thing that you need to really write when you create your own function is going to be return type of your function, and that is going to be void for now, which means that this function is not going to return anything. And we are going to talk about return types more in detail later in this course. So for now, we are going to use void return type, meaning that this function that we declare in this line is not going to return anything. And then you write out the name for your function, and let's call it function, like this. And then in these parentheses, you can put arguments or parameters that your function really receives. And for now, these parentheses are going to be empty, meaning that this function does not receive any arguments. And then in these curly brackets, we are going to put the body of our function. So this here is going to be the function that we created ourselves, and you have to specify the return type of your function. After that, you write out the name of your function. Then in these parentheses, you can put any arguments that your function receives. In this particular case, these are empty, and we are not going to send any parameters to our function. And then here is going to be the body of your function. And what we are going to put in this body, let's say cout hello from function, like this. And let's also add end line at the end of this function. So now we have really created our own function, which is called function. And if I run my program now, what do you think that is going to happen? Write that in the comments down below. So I am going to run this program, And as you can see, nothing has changed really. Our program has written out hello from main as it did before, so before we created this function. That is because, as I explained, your function is not going to execute until you call that function. So until you invoke it, it is not going to execute. So in order for our function to be executed, we need to invoke that function. And how that is done, so here in this line after hello from main, we are going to put function and then these parentheses. So this here is the invocation of our function. And now our function is going to be executed. So now if I press this play button, you can see that now our console has changed. So now we have hello from main and then also hello from function. So that is because we have invoked this function here. And you can invoke this function wherever you need it. So you can, I have invoked it after this line here, but you can invoke it as well before this line here if you need to and if you want to. So now if I run my program, you can see that it first says hello from function and then it says hello from main, because this function has been invoked first and then we have written out this line of code here. And that you can see in this console window. And let me show you one thing. So I'm going to return this after this line of code, the invocation of our function. I'm going to return here. And now I'm going to take this code here, so this definition of our function, and I'm going to paste it after our main function. And let's see what is going to happen now. So let me delete these blank lines. And now if I run my program, you can see that our program has failed to build. So we have compile time errors. And in this window here, in this error list, you can see that it says function identifier not found, which means that this function here is really, our compiler does not understand what this function is, because C++ code is executed from top to bottom. And when it comes to this line here, so when it comes to the invocation of your function, it is really not familiar with this function. It does not know what this function is. So you have to either put this code before your main function, as we did before, or you have to do other thing, which is really the recommended way to create your functions. And that would be to create definition and declaration of your function. So what are definition and declaration of function? Declaration of function is going to be really this here. So I'm going to copy this and put it before our main function. And this declaration of function is going to tell to your compiler what is going to be the return type of your function, what is the name of your function, and then if there are any parameters that your function really receives, you are going to put those in these parentheses here. So that is going to be declaration of your function. And that part, declaration of your function, goes before your main function. And after that, you are going to write the definition of your function, and the definition of your function is going to go after your main function. And in that way, you are going to make your code more readable, meaning that when someone else comes to your code, and if your code had 200 or 300 or 400 lines of code, then it would be really hard to read that code, and for someone it would be really hard to manage and go through your code. So he is going to find it much easier if he has all the declarations of your functions before your main function. And then if he needs to read a specific definition of a function, he can right-click the name of that function and click Go to Definition. And then he is going to be taken to the definition of your function, so the specific one that he needs to read, so that you don't bombard that user with all the functions, all the definitions of the functions that you have in your program. And in this particular situation, it is only one function, but your program is going to consist usually of more than one function. And that is really unreadable when you find a lot of definitions of a functions before your main. So you can right click on your function and say go to definition, or you can press F12. So you can click on your function and then press F12 and you are going to be taken to the definition of your function. Okay, so this here is the recommended way to create functions. And now if I press play button, you can see that our program has executed, actually has written out the same as it did before. So we have really removed that error that we had when we moved this definition of a function after our main, because we have added this declaration of a function before our main function. And there is really the most important thing that I want to mention in this video, and that is going to be what is the reason why functions exist. Okay, so we have seen that they make your code a bit more readable, so they group the parts of your code together so that you can manage your code easier. And the most important characteristic of functions is that they make your code reusable, meaning that you can write a specific code once, so you can solve a specific problem once, put the solution, the algorithm, the code for that problem in a function, and then you can really invoke that function however many times you need it. So here I can really copy this and then paste it, let's say 3 times if I needed it. And then if I run my program, you can see that this function has been executed 3 times here. And that is really the most important thing about functions, which means functions make your code reusable. You don't have to write the same code over and over again. And you should really try to group your code in functions so that each function does a specific task, nothing more than that. And in that way, you are going to make your code easier for yourself and for other people as well that are going to read your code. So I hope that you understood what functions are and how they are used. And we are going to talk about functions in more detail in my later videos. So make sure to subscribe to my channel and click the bell icon, because only then you are going to be notified when I publish my next video. And also follow me on my other social media platforms, so Instagram and Twitter accounts through Code Beauty. Thanks for watching, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another video of C++ functions. In this video, I wanted to talk about function parameters or arguments. And the first thing that I want to explain is what are parameters, so what are arguments. Sometimes a function needs to receive a certain value, a certain variable, and then perform a certain task on that value, so on that variable, or it really needs the value of that variable in order to perform a certain task. So let's explain how we are going to create a function that receives a parameter in C++. So here I'm going to add a function of return type void, and I'm going to say that that function is going to be called, let's say, introduce me, like this. And then in these parentheses here, we can put parameters that our function is going to receive. And after that, in these curly brackets, we are going to put the body of our function. So, as I said, in these parentheses here, we are going to put parameters, and they are specified in the following way. So first, you are going to write out the type of your parameter, and that is going to be string, like this. And then we are going to specify the name of our parameter, and that is going to be, let's say, name. So we want to pass in this function that is going to introduce our user, we want to really pass the name of our user. And then what our function is going to do, we are going to put in these curly brackets here, and that is going to be really to introduce our user. So our function is going to write out cout, let's say my name is, and then let's write out this name that we have received in this function. So I'm going to say name, and I'm going to add end line, like this. Okay, so this is the way to pass a parameter, so to pass a value to your function. And as I said in my previous video, you can really separate this declaration and definition of a function. So you can put really declaration of your function here, so before your main function, and then you can put definition of your function after your main function. And if you don't know how to do that, make sure to watch my first video of this playlist. Okay, so now I want to invoke this function here. And how we do that? Well, we specify the name of my function. So I'm going to say introduce me, and then since this function receives argument, so since this function receives a parameter here, we really have to pass that parameter to our function, and that I'm going to put here. So here I'm going to pass an argument to my function. So I'm going to say Saldina, like this, and this here really is called argument, so it is a value that we pass to our function, and then here it is called parameter. Okay, so now if I run my program, you can see that my function has successfully introduced me. So it says my name is Saldina, like this. Okay, so here we have really defined our function. So the parameters that our function receives, name, return type, and then the block of code that our function is going to execute. And then here we have invoked our function and passed an argument, which is this string of text here, to our function, which is going to be received in this name variable. And then our function is going to really treat it as a variable, which means that it is going to write that value here. Okay. And now if I try to invoke this function once more, so I'm going to copy this line and then paste it here, and let's say that I'm going to pass it a different value. So I'm going to say, for example, Anna. Okay, you can see that now our function has successfully introduced two users. So it has said my name is Saldina, and then my name is Anna. And there is also another thing that I want to explain, and that is going to be how you can pass multiple arguments to your function. And that is going to be in a following way. So here in these parentheses where I have specified my first parameter, you can put comma sign, and then you specify your second, third, fourth, fifth, and your other parameters. So you specify the type, which is also going to be string in this particular case. And let's say that my second parameter is going to be called city, like this. And let's add another one. So let's say int age, like this. So now in this function, I'm going to write out also where is my user from and also how old my user is. So I'm going to write out cout, I am from, and then let's write out this city that we have passed in this function and add also end line. And let's write out also I am age, so I am however many years we have passed in this function, and then let's say years old, like this. Okay, so now we have really introduced our user in more detail, and we have passed to this function name, city, and age information for our user. But as you can see here, our function, so our compiler really says that this function is not valid. It has too few arguments in a function call, meaning that this invocation, this call of a function, does not really contain all the necessary parameters or all the necessary arguments that we need to pass to our function, which means that it really lacks the city and age parameters. So here I'm going to put comma as well, and then I'm going to specify my city. This here is bolded, so it is bold, and that means that we have to really pass a city value to our function. So I'm going to write out Mostar, like this, and then I am also going to specify age. So I'm going to say 25. And let's do the same for our Anna user. So I'm going to say that our Anna is from New York, and let's say that she has 27 years old, for example. So now when I run my program, you can see that we have successfully introduced two users. So my name is Saldina, I am from Mostar, I am 25 years old, and then also my name is Anna, I'm from New York, and I'm 27 years old. Okay, so, and we have really written this code only once, and then we can reuse it however many times we need to. So in this particular case, we have used it 2 times. Okay, and another thing that I want to explain is going to be a default parameter. So what is default parameter? Sometimes you really don't want to pass a value to your function, meaning that in a specific situation you don't have that value or you don't want to pass it, and in that case you want to define default value for your parameter. So in the case where your user does not pass that argument to your function, for example, you can say that your age parameter here has the default value of 0, okay, and that means that you don't really have to pass this age parameter anymore. So here I am going to delete this age for my Anna user. And let's run our program now in order to see how this function is going to behave for this first user, and then also to see how it is going to behave for this second user which did not specify this age parameter, so this age argument. And when I run it, you can see that my first user has been introduced as it was previously, so I am 25 years old, and then the second user, which did not specify age argument, it really said I am 0 years old, meaning that our function has really taken this default value and it has written out I am and then this default value and then years old. Oh, we are missing S here. Okay, so I'm going to add S, and I want to do a following thing. So in the case where our user does not pass this value for our age parameter, I'm going to really check whether we have that value or we have this default value. And then in the case where we have only this default value, I don't want to write this line of code here. So I am going to say here, if age is not equal to 0, meaning that our user has specified some other value which is not 0, then and only then we are going to write this line of code. But in the case where we have only this default value, we do not really want to write out that our user has 0 years old, because that does not make sense. Okay, so as you can see now, my first user has been introduced as I am 25 years old, and then my name is Anna, I am from New York. Since Anna did not specify how old she is, we haven't written out her age here because of this check that we have added. Okay, so that was about default parameter, and there is one thing also that I want to say about this default parameter, and that is going to be really, if I delete this is equal to 0 and then I try to assign default value to this city parameter, so I say, let's say that city is equal to default, like this, you can see that the compiler is really underlying this function, and it says, okay, it says default argument not at end of parameter list, meaning that you can specify default argument only at the end of this list. So if you want to specify default value for this parameter, you will have to specify a default value for this one as well. So if I add default value here, so I have added 0, then we can really add a default value for this second parameter, and then we can add default value for this one as well. And now we are really left with, so our compiler is not underlying this introduce me function name anymore. Okay, and this does not make sense, so I'm going to delete it, but I wanted to explain that you cannot specify default value for your middle parameter if you did not specify a default value at the end of your parameters list. And there is one more thing that I want to show you, and that is going to be that you don't have to hard code these values as we did here. So I'm going to comment these out, and then I'm going to let my user define his own values for these 3 variables. So I am going to declare two variables of type string, which are going to be name and city. And then also I'm going to declare a variable of type int, which is going to be called age. And then I'm going to say cout, so please enter a name, like this. It's not capital letter, okay. And then cin name, and then cout city. So after my user has entered name, I want him to enter city. So cin city, like this. And then also I want to enter age, and cin age, like this. So now, after my user has specified these three variables, so name, city, and age, I can pass these three in my introduce me function. So I can say introduce me, and then pass name and city and age, like this. And if I run my program now, as you can see, my program really asks me to enter a name. So let's say that name is going to be Tom, for example. And then let's say that city is going to be London. And age, let's say 32. Okay. And now, as you can see, my function has successfully introduced Tom. So it says, my name is Tom, I am from London, and I am 32 years old. Okay. And you don't really have to use these names for the variables in your main function. So the names of these variables here do not have to be the same as these names here. So you can call these, for example, name 1, city 1, age 1, but you are going to have to use these names in your main function. So you will have to say name 1, city 1, age 1, and here as well. But these names do not have to be the same as these names here. Your program is going to work correctly. You have to, however, have the same type here and here. So this here has to be string if it has been declared as string here, and this one as well. And then age also has to be of type int if it has been declared as int here. And once more, if I run my program, you can see that it asks for name, so Tom, New York, and then age is going to be 22. And as you can see, my name is Tom, I'm from New York, I am 22 years old. So your program works just fine. So I hope that you have understood how parameters behave in a function, and how you can pass multiple parameters to your function, and also how you can specify a default parameter in your function. And if you enjoyed this video, if you learned something new, make sure to subscribe to my channel, click the bell icon so that you are notified when I publish my next video. Also like it and share it with your friends. And follow me on my other social media, so Instagram and Twitter accounts, True Code Beauty. Thanks for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel, welcome to another video of C++ functions. In this video I wanted to talk about return statements and return types of a function. So what is return type of a function? Well, return type of a function can be any data type that can be used in order to declare variable. So it can be int, float, bool, char, double. It can be any user-created data type, and it can be void as well, which means that that function is not going to return anything. And as we explained in one of my previous videos, function is a block of code. It is a code that is grouped together, and that code is going to perform a specific task. And here I want to make a difference between functions that return value and functions that don't return value. And functions that don't return value can be, for example, an example of a function that does not return value can be a function that writes out a menu to your user. So you call that function writes out a menu to your user, and the job of that function is done there. So you are not expecting any value to be returned from that function. But an example of a function that returns a value can be a function that performs a specific calculation, let's say on arguments that you pass to that function, and after that calculation is performed, you are expecting a certain value, so result of that calculation, to be returned from that function. And an important thing is that function can return only one value. So only one return statement inside your function is going to be executed. And I'm going to show that on the example that we are going to do in this video. And now I'm going to show you really how functions make your code easier to read, easier to understand, and how they make your code reusable. So we are going to show that on an example, which we are going to first make without using a function. So we are going to make a program that is going to determine whether a number is prime number or not, and we are going to do that first without using functions, and then I'm going to refactor that program so that it uses functions, and then I'm going to show you how that program becomes instantly more readable, more understandable, and also how that makes your code reusable. So as I said, we are going to create a program that is going to determine whether our number is prime number or not. And the definition of a prime number is a number that is divisible only by itself and by 1. So if that number is divisible by any other number, so not 1 and not itself, but any other number, that means that that number is not prime number. So the first thing that I'm going to do here is I'm going to declare a variable of type int, call it number, and then I'm going to let my user enter that number. So I'm going to write out the message to my user and then use the cin command in order to get that number and store it in my number variable. And then let's explain the algorithm that we are going to use in order to determine whether that number is prime number or not. The definition of a prime number is a number that is divisible only by 1 and by itself, which means that if you can find any other number besides 1 and that number itself that you can use to divide it by this number that our user has entered and get the remainder of 0, that means that this number is not prime number. So how we are going to solve this problem? Well, we are going to iterate through all the numbers between 2 and this number minus 1, and then we are going to check whether this number is divisible by that counter value. So I'm going to write out for int I is equal to 2, and then I is less than number, and in each iteration I want to increase the value of my I counter. So why haven't I used 1 here, and why haven't I said here that this I is less than or equal to the number? Because every number can be divided by 1, so we do not need really to check that. And also every number can be divided by itself, and we do not need to check that as well. So here we are going to iterate through this interval, so between 2 and while I is less than that number that our user has entered. And here we are going to check whether this number that our user has entered can be divided by any value of our I, so in any iteration which we are going to go through. And in the situation where it can be divided, we are going to use a flag, which I'm going to declare here. And that flag is going to be of type bool, and let's call it is prime flag, like this, okay? And this flag is initially going to be assigned a value of true. So we are going to initially say that all the numbers are prime numbers, and then we want to prove that wrong for the numbers that are not. So we are going to use this flag in a following way. Here I'm going to check in each iteration if our number that our user has entered can be divided by that current counter, so by the current value of I. So I'm going to use this modulo operation, and I'm going to say if this number modulated by I is going to give us the result of 0, so when you divide this number by I, do you get the remainder of 0? And if this operation here results as true, we are going to say that our is prime flag is going to be false. So we are going to assign the false value to our is prime flag because we have clearly found one number which is not 1 and that number itself that can be used in order to make this condition true. So here I'm going to write out is prime flag, and then I'm going to assign it a value of false. And then another thing is going to be really if we find one number, so even one number is enough to find that really fulfills this condition here in order to say that our number is not prime number. And in that situation, we do not really need to check any more numbers because we have determined that our number is not prime number. So here I can use break statement. So I can say, if you find only one number, please do not iterate through this for loop anymore because we do not need to find any more numbers. So in this situation here, we have iterated through all the numbers between 2 and that number that our user has entered. We have checked whether that number can be divided by any value of our I counter. And if it can be divided, meaning that it gives the remainder of 0 after that division, we are going to set our prime flag to false and we are going to break from our for loop. And after we have successfully fulfilled this, so after we have successfully iterated through this for loop, or we have fulfilled this condition in one iteration, we are going to leave our for loop and we are going to come to this line of code here. And here I want to check what has happened with my is prime flag, meaning I want to check whether this is prime flag has stayed true, which means that our for loop has executed all of its iterations and it has not found any number that can be really used to fulfill this condition here. And in that particular situation, that flag is going to stay true. And that is going to mean that our number is prime number. So here I'm going to write out if is prime flag, meaning if this value here, if this variable here holds the value of true, we are going to write out cout like this, and we are going to write out prime number like this. Okay, and let's also add end line here. But in a situation where this here does not hold a value of true, that means that in one iteration, so it can be the first one, it can be the last one, it can be any in between, we have really found at least one number that can be used to fulfill this condition and that has set our is prime flag to false. And in that situation, we are going to use our else statement and we are going to copy this and we are going to really modify it to say not prime number, like this. Okay, so now if I run this program, you can see that it asks us to enter a number. I'm going to enter a number, let's say 5, for example, and it says that 5 is prime number, which is correct. 5 is a prime number. And let's run it one more time. And let's say that we want to check 6 this time. And as you can see, our program has written out that 6 is not prime number. And 6 really is not prime number because it is divisible by 2 and by 3, besides from 1 and itself. Okay. So now you have seen how we can really solve this problem. And let's try to refactor this program here in order to use functions. So how we are going to do that? Well, the first thing that we need to do is we need to create a function, and I'm going to do that here. And since this part of code here, this is the part of code that we are going to move to our function. And since this part of code here determines really whether our number is prime number or not, and then sets this flag to true or false, let's say that we are going to create a function which is going to check as well whether the number is prime number or not, and then it is going to return a value true or false, meaning the number is prime number or the number is not prime number, and that we are going to write here. So here I'm going to put the return type of my function, and that is going to be bool. So that is the return type of my function, and then the name for my function is going to be is prime number, like this. And then let's say that we want to pass an argument to that function, and that argument is going to be of type int. And that argument is going to be really the number that we want to, check. So we are going to pass the number to our function. That function is going to, in this body here, check whether that number is prime number or not, and then it is going to return bool value, meaning true or false. So if the number is prime number, it is going to return true, and if the number is not prime number, it is going to return the value of false. And how we are going to do that? Very simple. So you see this code here. I'm going to comment this code here, and I'm going to really, no, I should have copied it before. So I'm going to copy this code here, and I'm going to move it to my function, okay? And we have previously explained this code here, so we do not need to explain it again. But what I'm going to say here is after this algorithm is done, so after we have really stored the value of true or false, so we have stored the value of false in our isPrime flag, or we have really kept this true value inside our isPrime flag, what we need to do is we really just need to say return isPrime flag, like this. So after we have checked whether our number is prime or not, we can really just return that value from our function. Okay, so we can now, after we have moved this code to our function, we can delete it from here, like this. Okay, and then as you can see, we have been left with this isPrime flag, which is not declared now. So identifier isPrime flag is undefined, meaning that now we have to really declare it, and we have to assign it a value. So I'm going to say here, bool isPrime flag, like this, and then the value that I'm going to assign to my isPrime flag variable is going to be whatever value our function returns. So here I'm going to say, please call my function isPrime number. Oh, isPrime number, like this. Okay, and then pass to that function this argument here. So our function expects a value, and that is going to be this number that we want to check whether it's prime or not. And then after this function here is done, it is going to return a value of either true or false, and that value is going to be stored inside our isPrime flag variable. Okay, so now if I run my program, you can see that it asks us again to enter a number. So I'm going to say, let's check number 9, for example, and it says that number 9 is not prime number, which is not, because it is divisible by 3. And let's check number 13, for example, and 13 is prime number. Okay, so after we have really used this function in order to perform this particular task, I want to show you one more thing, and that is going to be how we can refactor this function here in order to make it even more simple. And if you look at this function here, you can see that this isPrime flag is set to true here, and then in this situation where we find number that can be used to fulfill this condition here, we set that isPrime flag to false, and then we use this break statement in order to break our for loop. So we are not going to iterate anymore through our for loop when we come to this break statement. And then we really go here, and then we return that isPrime flag. But we can do that in a more simple manner, and that is going to be really here. So here, in a situation where we find number that is really fulfilling this condition here, we can say, at this very line of code, we can say return false, like this, because this code here we can delete. And why I can use this return statement? Because this return statement is going to really break our for loop, and it is going to return the value from our isPrime number function, meaning it is going to do two things. So we do not really need to set the flag and then return the value of that flag at the end, but we can really say, if you find any number that can fulfill this condition, return false immediately. So break for loop and also return the value from our function, meaning end the execution of that function, because we have found our result. And then here as well, we do not really need to declare this isPrime flag to true and then return it, because it is clearly true. So we can say here, return true, and then remove this flag from here, like this. And then as well, I can remove these curly brackets and make my code even more readable. So now I want to explain what we have done. So here we are passing a number to our isPrime number function. Then we are iterating through all the numbers between 2 and that number. We have skipped 1 and that number itself because all the numbers are divisible by 1 and by that number itself. And then we are checking whether any of these I values between 2 and number fulfill this condition here. That would mean that that number is divisible by that current value of I, and that would mean that our number is not prime number. So at that very moment we can say, please return false, because this number is clearly not prime number. But in a situation where this for loop has really iterated through all of its iterations and it has not found any number that fulfills this condition here, that means that this return false statement has not been executed, and then in that particular situation, this return statement here is going to be executed, and this return statement here says return true. Okay, so this part of code here has not changed, nor it is going to change, and if I run it again, you can see it asks me to enter a number. I'm going to enter number 7. Then it is going to check whether that number is prime number, so it is going to call our function and assign the result of that to our isPrime flag variable. And I press enter here. You can see that we get the result prime number because 7 is prime number. Okay, and that is really making your code much more readable and reusable as well. So this main function here is much more clean than it was before. And now I want to show you the most beautiful thing, and that is going to be how we can make this isPrime number function reusable. So let's say that I am going to delete all of this code here. So I'm going to delete it. And now I know that I have written out this isPrime number function, and I know that I can really invoke this function and use it whenever I need to determine whether some number is prime number or not. So let's say that now we want to check all the prime numbers between 1 and 1,000, for example. So how we are going to do that? Well, we are going to iterate through all the numbers between 1, so I is equal to 1, and then I is less than or equal to 1,000, and increase our I in each iteration by 1, like this. And then in each iteration, I really am going to just send this I to my function, and I'm going to really get the result from this function. So this function is going to tell me whether that I is prime number or not. So here I'm going to declare a variable of type bool, and I'm going to call it is prime, and I'm going to assign to that variable a value of is prime number when I pass it the value of I. So whatever this function here returns, whatever this function here results in, I'm going to assign that result to my isPrime variable. Okay, and now what I want to write out is all the numbers that are prime numbers between 1 and this 1,000 value. So I'm going to say if is prime, like this. I'm going to write out cout, and then I want to write out the current value of my I counter, because that is the number that we are talking about. So I is prime number, like this. Okay, and I'm going to add a new line at the end. So this code here is really going to check all the prime numbers between 1 and 1,000, and it is going to write out all the prime numbers in that interval. And for solving this particular problem, so whether the number is prime number or not, we have used this isPrime number function, which we have written once, and we have really tested it once. We know that it works as it should, and now we can really close it. We do not need to really think about how we are going to perform this task, never again. So we have written it, we have tested it, and now we have this algorithm stored in our isPrime number function, and we know that this function works in a following way. So we pass it a value, and then this function returns us true or false variable, meaning that the number is prime number or not. So once more, if I run my program, you can see that we have gotten the expected result. So we have gotten all the prime numbers between 1 and 1,000. Okay, and there are a lot of numbers, okay? So you can check these numbers on your calculator if you want. And let's say now that we really want to check all the numbers between not just 1 and 1,000, but let's say 1 and 10,000 or 100,000, okay? We can call just this is prime number function, pass it the value of our I, and then check the value that this function has returned. And this function has really told us whether the number is prime number or not, and if the number is prime number, we just want to write that number out to our user. So if I run this function again, you can see that it is writing out all the prime numbers between 1 and 100,000, and there is a lot of numbers again. So you can even count how many prime numbers there are in this interval, so between 1 and 100,000. And let's say that I'm going to leave that part to you. So if you want to really upgrade this program so that it counts how many prime numbers there are in this interval, you can write that code in the comments down below, and I'm going to check it, and as well you can leave it for other people to see and use if they need it. So I hope that you have understood this return type of a function, and in this particular situation it was bool type, but you can have as a return type from your function, you can have any other data type. So you can have float, char, int, string, whichever data type you can really use in order to create a variable. You can use that data type in order to be a return type of your function. So in this particular situation, I wanted to show you an example of a bit of a more complex function, let's say, that is going to determine whether your number is prime number or not, and it is going to really receive that number that you want to check as an argument, as parameter, and then it is going to return only true or false, meaning that number is prime number or that number is not prime number. And once you have written this code and once you have tested it, you do not really need to bother with this function anymore. You do not need to remember this code, nor read it, nor even understand it in order to use this function. Only in a situation where you have a bug, and that bug is in this particular function, only in that situation you are going to need to really reread this function and fix that bug. In any other situation, you can really just use this is prime number function. And as well, we could have made other functions with other return types. We could have created, for example, a function that is going to sum two numbers. So you are going to pass to a function two numbers, let's say number A and number B, which your user enters. And then that function is going to sum those two numbers, and it is going to return the result to your main function from where you are going to invoke that function. And as well, I can leave that to you so you can really practice writing functions on that example, for example, and you can put the code for that exercise in the comments down below as well, and I'm going to check it. And in this particular example, as I said, I wanted to show you a bit more complex example so that you can really understand why we need functions and why they make our code understandable and reusable. And if someone else comes to your code now and he sees that he has is prime number function, he does not really need to open this function and read how this function works. It is pretty clear from this declaration itself that this function receives a number and determines whether that number is prime number or not, and returns that true or false back to the invoker, back to the function that invoked this is prime number. Okay, so I hope that you liked this video. I hope that you enjoyed watching this video. If you did, make sure to like it and also subscribe to my channel and follow me on my other social media, so Instagram, Twitter account at TrueCodeBeauty. The link is going to be in the description, and I'm going to see you in my next video. Bye. Hi everyone, welcome to my channel. Welcome to another C++ functions video. And in this video I want to talk about a concept that is related to functions, which is function overloading. So I want to first explain what function overloading is. It means that you can create multiple functions with the same name, but those functions are going to have different parameters. So here I have opened my Visual Studio, and let's create a function which is going to be called for example, sum, and I'm going to put the return type of that function to be int, so integer. If you're not familiar with function return types, I'm going to link that video here, so make sure to watch it. So first thing, we write the return type of our function, and then we write the name of our function, and as I said, our function is going to be called sum, and then I want to pass parameters to this function, so I really want to declare which parameters this function is going to receive, and those are going to be two parameters. The first one is going to be integer, and I'm going to call it a, and then the second one is also going to be integer, and I'm going to call it b, like this. So this is going to be our first function, and let's also say that we want to create another function, which is also going to be called sum, but this time it is going to be of return type double, like this, and then I'm going to call it sum, as I already said, and this function is going to receive two parameters as well, but those are going to be of type double. So I'm going to say double a and then double b, like this. Okay, and as you can see, these functions are underlined because it says function definition for sum not found, meaning we have declared our functions here, but these functions are missing the definition. So definition is missing for this function and then this function as well. And let's also create one more function. So I'm going to say, for example, float, and then I'm also going to call it sum. And let's say that this time I'm going to give it three parameters. So I'm going to say float, let's say float a, and then float b, and then float c, like this. Okay. And then what I want to do is I want to create definitions for these functions, which I'm going to do here. So the first one that I want to define is going to be this one here. So I'm going to copy its declaration, and then I'm going to add these curly brackets. And here I'm going to put a definition for this function. So let's say that I'm going to create a variable of type int, and I'm going to call that variable result, like this. And I'm going to assign it the result of a plus b, like this. And then what I want to do is return this result from my function. So here I'm going to say return result, like this. So this would be one way of returning the result from your function. And then another way to do the same thing is going to be to say really return here. So instead of creating a variable that is going to hold this result, you can really return this result itself from your function. So you can say here return a plus b, and now we can delete this line, and as you can see, this function became shorter and more readable. So now I want to define this function here, so I'm going to say double, okay, I should have copied this, and then double b as well, like this. So here I want to put the definition for this function here, and this function, oh, I'm missing the name for my function. It is called sum. So this is return type, this is the name of our function, and then these are parameters of our function. And here I want to say return a plus b as well, but this time our a and our b are going to be of type double. So in this situation there were integers, and then in this situation there are decimal numbers. Okay, and let's also create a definition for this function here, so this float function, and this time I'm going to copy it, okay, and I'm going to add these curly brackets, and here I want to write return and then a plus b plus c, like this. Okay, so now how we are going to test this, we can call these functions, we can invoke these functions here in our main function. And the first one that I want to invoke is going to be our int function. So I'm going to say cout, and then this line of code is going to really write out whatever our function returns. So I'm going to say please write out whatever my sum function returns, and then I want to pass to my sum function two numbers, and those two numbers are going to be two integers. And as you can see here, we have really help from our IntelliSense, which says you have three possible functions that you can call. So you have overloaded three functions, and you can navigate through these using your arrows. So the first one is going to be our function that has float return type, and that function receives 3 parameters of type float. And then the second one is going to be the one that has return type double, and that function receives 2 double parameters. And then the third one is going to be the one that returns integer, and that function receives 2 integer values. So here I want to call our integer function, and I want to pass to that function 4 and 3, for example. And let's also add end line like this. And now if I run my program, we can expect to see the result of this line of code here. And as you can see, the result is 7, meaning that our function has been invoked, and then this line of code has received the result of summing these two numbers, and that has been written out in our console, and the result of summing 4 and 3 is 7. Okay, so now I'm going to stop this console, and I want to test these other two functions. So I'm going to say cout, and let's test our sum function that receives 2 double parameters. So it is going to be this one here. So I'm going to say 4.4 and then 3.3, for example, and I'm going to add end line at the end as well. Okay, and now if I run this program, you can see that our second line is 7.7, meaning 4.4 plus 3.3 is going to be 7.7, which is correct. So we have successfully tested this function here, so this double function that returns double and receives also 2 double parameters. And then let's also test this third function. So here I want to say cout sum, and then here I want to pass 3 parameters. The first one is going to be, let's say, 4.4, and then the second one is going to be 3.3, and then 3 decimal point 3.3, and then the third one is going to be 2.2, for example. Okay, now this invocation should invoke this float function. So when I run my program, as you can see here, this third line contains the result of summing these 3 numbers, and you can check this out using a calculator, but this is the correct result. So as I already explained, this represents function overloading, and we have created 3 functions. The first one is the one that receives int types and returns int type as well. Then the second one receives double, so 2 double variables, 2 double parameters, and returns double as well. And then the third one really contains 3 arguments, so 3 parameters, but it has the same name as these previous 2. And then it returns float type as well. And then now when we invoke those functions, we can really pass different data types, and depending on those data types, we are going to call adequate functions. So in this first line, we are going to invoke this, and then in this second line, we are going to invoke this, and then in our third line, we are going to invoke this. Okay, so I hope that you understood what function overloading is, and also I hope that you have understood that you don't have to create functions with different names when they are doing almost the same thing. So these 3 functions, these 3 are doing the same thing. They are summing the numbers that we pass to them. Only in this particular situation, the first one is summing integers, the second one is summing decimal point numbers, and then this third one really sums 3 numbers. And we have overloaded this sum function, and we didn't have to create functions that are, for example, sum int and then sum double, and then sum float, like this. So we didn't have to name these like sum int, sum double, and sum float, but we can use the same name as long as we have different parameters, different number of parameters, different return type, or something similar. In that particular situation, our compiler is going to decide on its own which function it should call. I hope that you have understood what function overloading is and how you can use that. Thanks for watching, and I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina, and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. Now in this video, I want to show you how you can build an ATM application. And the first thing that I want to do in order to build this application is going to be to plan the functionalities that this application is going to have. So I'm going to put a comment here, and then here we are going to write all the functionalities that our ATM is going to have. So the first one is going to be to check the balance. So I'm going to write that. So check balance. And then another functionality is going to be to deposit money. So let's say deposit like this. Okay. And then what else? Well, we should be able to withdraw money as well. So let's write that. Okay. And I definitely want to show the menu to my user. So I'm going to write that as well. So I'm going to say show menu like this. Okay. Now, after we have written these functionalities that we want to implement, the first one that I want to implement is going to be this show menu function. So I'm going to put the code for this show menu functionality in a function, and let's create that function here. So I'm going to say void. It is going to be of void return type. Let's call it show menu like this. Oh, like this. Okay. And then what I want to do here is I want to write out the menu to my user. So I'm going to say cout, and then let's add these star symbols. 4, 5, 6, 7, 8, 9, 10. That is going to be enough. Like this. And then I'm going to copy this on the other side so that it looks proportional. Okay. And then the first option that I want to write out to my user is going to be let's add first and then check balance. So that is going to be the first option that our user can choose. And then let's add a couple more of these. So the second option is going to be deposit. So I'm going to write that like this. And then the third option is going to be to withdraw. So I'm going to copy this here and then paste it here. Okay, and then let's add these star symbols at the end of our menu, like this. Okay, now, after we have created this show menu function, what I want to do is I want to invoke this function. So here I'm going to say show menu, like this. Okay, and if I run my program, as you can see, we have this menu shown to our user. Now, what should happen next is we should allow our user to choose one of these three options. So the next thing that I will do is I will create a variable. So let's create it here. Let's say int, and that variable is going to store the option that our user chooses. So I'm going to call it option, like this. And then here, after I have written out this menu, so this menu here to my user, I'm going to say cout, and then please choose an option or whatever message you want to show. So option, like this. And then I want to accept the value that my user enters in this option variable. So I'm going to say cin option, like this. Okay, now if I run this program again, as you can see, it asks for option, and if I select any of these three options, if I press 3, for example, you can see that my program closes because we haven't written any code after this line here. So what I want to do now is I want to handle these three options, and I'm going to handle these three options using a switch case. So I'm going to write switch, okay, and then here I want to put this option variable. So that is going to be the value that I want to check. So I'm going to say switch option, and then in the case that our user has entered option 1, what I want to do is I want to write out the balance to my user. And in order to do that, I'm going to create a balance variable because we do not have a balance variable yet. So I'm going to give it a type double like this and call it balance. Okay, and let's assign it initial value of, for example, 500. Okay, so that is going to be the initial value of our balance variable. So here I'm going to say cout, and then let's say balance is, okay, and then let's write out this balance variable, and I'm going to add this dollar symbol at the end, and I'm going to add end line as well. Okay, so that is going to happen in the case that our user enters value or option 1, and I'm going to add break at the end of each case, so here as well. Okay, now our second case is going to be when our user enters option 2, like this. So in that second case, we should allow our user to deposit money. So here I'm going to say cout, and then let's write out deposit amount. So we want to ask our user how much money he wants to deposit. So in order to accept the value that our user enters, I'm going to create a variable which I'm going to call deposit amount. So let's create that variable. It's going to be of type double, and it is going to be called deposit amount, like this. And then I'm going to accept the value that our user enters here in my deposit amount variable, like this. Okay, and now what I want to do with this deposit amount is I want to add it to my balance. So I'm going to say balance is now going to be equal to whatever my balance was previously holding plus this deposit amount, like this. And then let's add break at the end as well. Okay, and then our third option, our third case is going to be when our user wants to withdraw money. So I'm going to copy this case here and then paste it here. And here I want to write out a different message to my user. So I'm going to say withdraw amount. Let's copy this. Okay, and then this variable, I'm going to call it withdraw amount, like this. Okay, and then here I want to enter that withdraw amount. And what I'm going to do with my balance in that situation is going to be I want to subtract that withdraw amount from my balance. But I want to subtract that withdraw amount only in a situation where this withdraw amount is equal to or less than this balance. So I'm going to say here if withdraw, where it is, withdraw amount is less than or equal to balance, like this, then I want to give that money to my user. Else, meaning if our user has requested more money than he has, I'm going to write out a message. So I'm going to say not enough money, like this. Okay, and that is going to happen, so this code here is going to happen in the case that our user enters option 3, which is this one here. Okay, so now if I run my program, you can see that it asks option, and let's say that we want this first option, so this check balance, and it says that balance is 500. And if I press anything else, as you can see, my program is going to close. And that is because we haven't implemented any loop that is going to iterate this code here. So let's add that loop now. So here I'm going to say do. So do while loop is the one that I want to use. And then inside my do while loop, I'm going to put all of this code here. So let's add a curly bracket, close curly bracket at the end, like this. And then I'm going to say, please do this block of code here, while, and then I want to do this code here while the option that my user has option that my user has entered is not equal to 4. And when my user enters option 4, we should stop the execution of our program. So in order for our user to know that 4 means exit, we are going to write that here in our show menu function. So here I'm going to add this fourth option, which is going to exit our program like this. Okay, now if I run this code, you can see that it says that it has this menu here, and then it asks for option. So I'm going to enter option 1, for example. Okay, and this option 1 says that balance is $500. Now let's enter this second option. Let's enter this deposit option. So I'm going to press 2, and as you can see, it says please enter deposit amount. So let's say that I want to deposit $700, for example. Okay, now if I check my balance again, so I have entered this option 1, and then I press enter, as you can see, it says that my balance is $1,200. And there's one thing that I want to do with this program, because I don't like the way that this looks. It is not really readable. So I'm going to add clear screen, so clear console command, and I'm going to add that here. So after my user chooses his option, I want to clear the console. So I'm going to say system, and then let's add CLS, which is a command that is going to clear my console, clear my window. So if I run my program again, as you can see, again, we have this menu, and then it asks us for the option. So let's say that I want to check my balance. It says that my balance is $500. Now let's try to withdraw money. Let's say that I want to withdraw money, and I want to withdraw $600, for example. And then it says not enough money because we had $500 on our account. So now what I want to do is, let's say, for example, that I want to deposit $100, okay, and then I want to withdraw $600. Okay, and if I check my balance now, as you can see, balance is 0. And in order to test this exit functionality, let's press 4, and then if I press enter, as you can see, my application is going to close. Now another thing that I want to check is going to be what is going to happen if our user enters option that is not valid, meaning an option that is not any of these 4 that we have covered here. So if I run my program again, as you can see, it asks us to enter option. So I'm going to enter option 5, for example, which is not valid, and nothing has happened. If I enter option 9, nothing has happened again. 99. Okay, now you get the point. What is happening here is our program tries to find this adequate option. So option 5, option 9, whichever one we have selected. And since that option does not exist in these cases here, our program continues to this while check, and then it checks that the option is not equal to 4, and because our option is 5 or 9 or 99, which is not equal to 4, then our do while iterates again, and then it writes this show menu again, and then it asks us to enter this option again. So these 3 options are the only valid options that you can select, and then 4 means that you are going to exit your program. Now here we have created this show menu function that has check balance, deposit, withdraw, and then this exit option. And what I want to suggest to you is how you can upgrade this program on your own. So for example, you can create 2 users, 2 accounts. And what you can do with those 2 users is you can implement transfer option, meaning transfer money from one account to the other account. And I'm going to leave that up to you. And if some of you decide to write that code, make sure to paste it in the comments down below, and I'm going to review that code, and some other people may find it useful as well. So I hope that you enjoyed this video. If you did, give it a thumbs up. Don't forget to subscribe to my channel and hit that bell icon as well. And I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if you're interested in those, please subscribe to my channel and give this video a thumbs up, because that helps me a lot to reach more people and spread programming knowledge. And in this video, I want to talk about generics and templates in C++. So what are generics? The idea of generics was born when programmers decided that they want to be able to use the same code but with different data types. So the logic is the same, but data types are different. Or if you want another explanation, when we talked about functions, we said that we can pass parameters to functions. And what we said as well is that types of those parameters had to be known beforehand. So you had to hard code types of those parameters, whether it is int or char or float or any other data type, that had to be known beforehand. But with this idea of generics, what we should be able to do is we should be able to pass that type itself to a function. So we should be able to determine which type we want that function to operate on. And the best way for you to understand this will be on an example. So that is exactly what I will do. So let's say that in my Visual Studio, I want to create a function that will swap the values of two variables. And if you don't have an idea how you can swap values of two variables, I have a video where I explain that in a very visual way, so you can use that video. I will link it here. So here I will just type very quickly the code for that, and if you need explanation again, you can watch that video. So I will say that that function will be of return type void, and I will call it swap. And then what I want to pass to this function will be two integer variables. So I will say int a and then int b, like this. Okay, but because I want to have both of these variables available in my main function, which will invoke my swap function, I will have to pass these two variables using a reference. And again, if you're not familiar with passing parameters by a reference, I will link another video here where I talk about that, and I think that I made more than one video on my channel talking about passing variables by a reference to a function, so I will put those in the description as well. So the code for this swap function will be the following. So I will say int temp, I will create a temporary variable, and to that temporary variable I will assign the value that my variable a is holding, and then I will assign to my variable a the value that my b is holding, like this, and then to my b I will assign whatever my temp variable is holding. Again, if you need to understand this in more detail, I will put video in the description of this logic here. Okay, so now this function should give us the ability to swap values of two variables, and the way to test this function is the following. So I will say, please create two variables, call them a and b, like this, and to my a variable I will assign the value of 5, for example, and then b will have the value of 7. So let's write out values of these two variables. Let's say a, and then just make a separation, and then value of b, like this. Okay, so now what I want to do is I want to invoke this swap function. I will say swap, and then I will pass my a and then b, like this. And if I copy this line after the invocation of my swap function, we will see if the values had indeed been changed. So if I run my program, as you can see, this line of code here has resulted with this output, so 5, 7, and then after invoking our swap function, the values inside these two variables, so a and b, have successfully been swapped. So now it is 7, 5. Okay, excellent. So that means that this function does what it should do. Now, what happens if I want to swap values of two char variables, for example? What I would have to do is I would have to copy this function, paste it here, and then I will adjust it to be able to work with char variables. So I will say char, and then I will change this with char as well, and then here I will put char as well. Now this swap function should work with char parameters, and this is called function overloading. If you're not familiar with function overloading, I made that video explaining how it works, so I will link it here if you want to watch it, and I will put it in the description as well. So this function should be able to work with char parameters now. And in order to test this function, let's create two variables of type char, so char C and then D as well. And to my C variable, I will assign the value of letter C, and then to D, I will assign the value of letter D. Excellent. So I will copy this line of code here, and I will just adjust it so that now we write out the value of our C variable, and then here we write out the value of my D variable, like this. And then after this line of code here, I want to invoke this swap function. So I will say swap, and then pass it C and D, like this. And I want to write out my C and D variables after this line of code here. So after I have swapped the values, just to check that they successfully have been swapped. So if I run my code, as you can see, we have this output here, so C and D. And then after swapping the values inside these two variables, we have this output here, which means that they have been swapped successfully. Now, I see a problem with this approach here, and the problem is following. What happens if I want, for example, to swap values of two float variables, and then two doubles, and then two booleans, and so on? Well, I would have to create this swap function for each data type. And that is repeating code, and we shouldn't really be repeating code unless we really need to, and in this particular situation we don't. So there is a simple solution for this problem, and that simple solution will be using generics. And the idea is to be able to use the same function, the same logic, but with different data types. So again, we will be solving this problem using generics. And the way that generics are implemented is using templates. So how do you make a template in C++? Well, you use keyword that is template, like this, and then inside these angled brackets, you will put the name of your type. So you will say type name, and most common type name that is used is called T, but you can use whichever type name you want. You can say type as well if you want, that should work, but I will use T because that is the recommended way. So now that I have created a template and I have said I want to create a new type, which is called T, I will have to use this T in my swap function. So now I will change this int with my T. So I will say T here, and then T here, and I will create T here as well. Okay, now this T is called generic data type, and this swap function is now a generic function, which means that this swap function can be used on any data type whose variables can be swapped using this logic here. So in one invocation it can be swapping integer variables, and then in another it can be swapping characters, and then in the next one floats, and then doubles and booleans, and so on. So now that means that we can really remove this swap function because we do not need it, because as we said, this function here is a generic function and it can be used with different data types. So now I will delete this swap function here, and if I run this code should work as it did before. So let's press this button. Okay, and as you can see, 5, 7, and then 7, 5. This function indeed works for integers, and then CD, and then DC, so it works for characters as well. And let's close this. Okay, now what you can do here as well, here in the invocation, in this 15th line, invoking this function for two integer variables, what you can do is you can specify the type itself as well. So you can say, I am invoking this swap function for my integer type. So now when this function is invoked, it will go here, and this T keyword will be changed with this int. So it will be int here, and then int here, and then int here, and it will do the swapping. This function here will do the swapping for int data type. And then in this 20th line here, you can say as well char if you want. You don't have to. That process will happen automatically because you have declared C and D as char type. So those C and D of type char will be passed here, and then char will be here, and char will be here, and then char will be here as well. So what we have acquired with this template function here is to be able to use the same code with different data types. We have just demonstrated how that can be invoked for integer data type, and then how we can use it for character, and you can do on your own float or double or bool and so on. Okay, and then what you can do as well is you can use any other name for your generic type. T is something that is used commonly in literature, but you can use type as well if you want. So you can say O, you can say type, and then you would have to say type here, and then type here, and here as well. Okay, that should work the same way that it did previously. And then another thing that you will find in literature is instead of this type name keyword, you can use class. It really depends on you. Whichever one you want to use, you can. And again, if you know what classes are, class is a type as well, so it is user-defined type. So this should work as well, the same way that type name keyword did. And if you're not familiar with classes and objects and object-oriented programming, I have a course which I will link here, so make sure to watch that. So I hope that this video helped you understand what are generics and templates and what is the main idea behind them. And we will be talking about this, of course, in my future videos and in more depth. So make sure to subscribe to my channel and hit that bell icon as well so that you don't miss a video that I publish. And if you like this one, please give it a thumbs up. That helps me to reach more people and help more people with programming. So thank you very much for watching, and I am going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos, so if that is something that is of interest to you, consider subscribing to my channel. And in this video I want to talk about recursion and recursive functions. In my previous videos we already talked about functions in general, so you should be familiar with that. And then in this video I want to show you on an example what is recursion and how it works. So what is recursion? Recursion is a process where a function invokes itself, and that function that invokes itself is called recursive function. That is pretty simple definition. So let's show that on an example. And the example that I want to give you today in this video will be to sum all the numbers between m and n, which are the numbers that our user defines. And the first thing that I want to show is we will solve that problem using loops, which is a solution that you should already be familiar with. And if you don't understand loops, you can find videos on loops in my C++ for Beginners playlist, so you can watch that. And then after we solve that problem using loops, I want to show you how you can solve that same problem using recursion. So if you want to skip directly to the recursion part, I'm going to leave the link to that part, the timestamp, in the description of this video, so that you can navigate yourself directly to the recursion part if you want. Now, as I already said, the problem that we want to solve in this video is going to be to sum all numbers between number m and n. So let's write the text of our task here. I'm going to say sum numbers between m and n. Okay, so this is going to be our task. And then here, as I already said, I will first solve this problem using loops. So considering that we have to sum numbers between number m and n, I will create two variables, so int m and n, which are two variables to hold the numbers that our user enters. You can do that part. I'm going to hard code those values here. So let's say that my number m, that my variable m holds value of 2 and then n holds the value of 4, for example. And one thing, if you are going to ask your user to enter the numbers for these two variables, what you should do is you should make sure that your user enters smaller number in your variable m and then greater number in your variable n. And if that is not the case, there are a few ways to solve that problem. So you can swap the values in these two variables if your user enters bigger number here and then smaller one here. And if you don't know how to swap the values in two variables, I'm going to put a link which contains the explanation for that here. And then you can as well just ask your user to enter again and again and again until this number is smaller and then this one is greater. And as I already said, I'm just going to hard code these two values here. Okay, so now that we have our number m and our number n, what I'm going to do is I will write a loop which is going to solve this problem here. And the easiest way to solve this problem here is going to be using for loop. So I will say for, and then I will declare a counter, int I, and that counter should start at the value of our variable m. So I is equal to m, and then it should count until it comes to the value of n. So while our I is less than or equal to n, so while our I is less than or equal to n, and then in each iteration I'm going to increase the value of my counter by 1. Okay, so what I should do in this for loop here is I will just sum all the values that my counter holds in a specific iteration. So I will create a variable here, which is going to be of type int, and I will call it sum. And initial value for our sum will be 0, because 0 is neutral when it comes to adding. So here I will write sum is equal to whatever our sum was previously holding, and then to that I will add the value of my I counter, like this. So this should be pretty much it to solve this problem, and at the end of this for loop we should have the sum of the numbers between 2 and 4 in this variable here. So let's write that out. I will say cout sum is equal to, and then write out the value that our sum variable holds. And if you're not familiar with this code here, you should watch my video related to for loop, and I'm going to link it here or leave it in the description down below. So let's run our program and test this code here. Okay, it says that our sum is equal to 9, so 2 plus 3 is 5, plus 4 is 9, so that is the correct result. So this approach here will solve this problem using loops. And this is something that you should already be familiar with. And now I'm going to show you how you can solve this same problem using recursive functions. So let's comment this code out because I don't need it anymore, like this. And then what I want to do is I want to create a function of return type int, and I will call it, let's call it recursive sum, like this. Okay, so this recursive sum function will receive two parameters, and those two will be integer number m and then integer which is called number n. So we will pass these two values to our recursive sum function. And what should we do inside this recursive sum function? Well, the same way that we do not want this for loop to be an infinite loop, we do not want our function to be an infinite recursion. So here we specify the condition when our for loop is going to stop to execute. So here, when our counter I reaches the value of n, that is the point when our for loop stops running. And then here in our recursive sum function, we will have to define a base case which is going to break this recursion. So as I already said, it is called base case, and for this recursive sum function, our base case will be following. So I will say if our m is equal to n, in that case, what I want to do is I want to return from this recursive sum function value of our m or n. So I will say return m. It doesn't really matter which one you return because here we have checked that they are equal. Okay, so this here is our base case, something that is going to break our recursion so that we do not end up with an infinite recursion. Okay, and then what I want to do here is I want to do that recursive part. So that part where the function is invoking itself. And what we should do here is the following. So I will say return, and here I want to return the value of m, so the current value of our m parameter, and then I will add to that the following expression. So I will invoke again our recursive sum function, but this time I will pass to this recursive sum function the value of our m plus 1 and then the value of our n variable. Okay, so what this code here is going to do? The same way that here we have increased the value of our I counter in each iteration, here I'm increasing the value of our m parameter in each recursion, so that at a certain point we are going to reach this condition here, so our m and our n will be equal, and at that point our recursion is going to stop. So how is this code here going to behave? Well, let's write out invocation of this function here, and then we are going to go line by line through the execution of this program so that you can understand how this recursion is going to work. So let's say cout sum is equal to, And then I will invoke this recursive sum. So recursive sum, and here I want to pass the value of m and n, like this. So when we come to this 14th line of code here, what is going to happen is we will pass values of 2 and 4 to this function here. So I will write that my m holds the value of 2, and then n holds the value of 4. Okay, and then we come to this line of code here, and we check, is our m equal to our n? So is 2 equal to 4? The answer to that is no, so we do not execute this, but we go here, and what this line of code here says, it says, please return from this function the following. So return current value of my m, which is 2, and then to that I will add whatever this recursive sum function returns to me if I pass it m plus 1 and n. So here I will invoke function again, and I'm going to use these parentheses to indicate invocation of a function. So here we are invoking recursive sum function again, and this time we are passing it values of m plus 1, which is 3, and then n stays the same because our n is our upper limit, so that we can know when we are going to break this recursion. So here is the invocation of this function again, and then we have entered this function using these two parameters. So we go here again and we check again, is our m equal to our n? So is 3 equal to 4? The answer to that is no. So we do not execute this line of code, but we go here again. And what this line of code here says, it says, please return current value of m, which is in this recursion 3, and then add to that whatever this recursive sum function returns for these parameters here. So here I will invoke recursion again, and I will indicate that again with these parentheses. So we invoke our recursive function again with parameters of m plus 1, which is 4, and then n stays the same. So we go here again, and we check, is 4 equal to 4? And the answer to that question now is yes. So now we return the value of our m, which is 4. So here I will say that this recursion returns the value of 4, and then we go backwards. So here we have all the invocations of this recursive sum function. So the result, the end result of this recursion is going to be the result of this expression here. So let's calculate what this recursive sum function is going to return finally at the end. So this is one recursion, and that recursion returns the value of 4. So I'm going to delete these parentheses, and then the recursion prior to that returned the value of 3 plus 4, which is 7. And then if we come out this recursion as well, so I will delete these parentheses, the result of our recursive sum function will be the result of this expression. So 2 plus 7 will be equal to 9. So this is going to be the result of our recursive sum function. So if I run my program now, we should get this 9 as the result of executing this recursive sum function. So let's run our program. And as you can see, sum is equal to 9. And if I increase these m and n values, so if I say, for example, please calculate sum between 1 and 4, we should get 10 this time. So 10, okay, and then here if I add number 5, for example, we should get value of 15, right? So we get that the result is 15. And what you can do here now, of course, you can say, please calculate some of the numbers between 1 and 551, for example, but this is going to be hard to check. So if I run my program, as you can see, we get this very, very big number. Okay. One very important thing that you must have each time that you work with recursion is the following. So every time that you work with recursion, you must have this base case here, which will stop the recursion from happening again and again and again. So this base case here will stop invoking recursive sum function at a certain point when a certain condition is reached. And unless you have that base case which will stop the recursion, you will have that function invoking itself infinitely, so infinite number of times, and you will get an error. So in order to demonstrate that, I will remove this base case here. So let's comment it out. And if I run my program now, as you can see, we get a Stack Overflow error, which means that, as I already said, this recursive sum function is invoking itself again and again and again, infinite number of times, and this recursion never stops. And in order to stop it, you need to have a base case which will stop the recursion. So I'm going to close the program now, and I will return this code here, which is our base case. And if I run my program again, as you can see, we get the expected result and the error has disappeared. So that is something very important to remember. Each time that you use recursion, you must have a base case to break that recursion from happening infinite number of times. So I hope that you understood what is recursion and how it works. And in order to practice on your own, I will leave a task for you, and the task is following. So I want you to do the factorial of a number using recursion. Calculate factorial of a number using recursion, and if you are not familiar with what factorial is or how it is calculated, I will leave a video link here where I'm calculating factorial of a number using loops. And then what I want you to do is to do that same task using recursive functions. And you can paste your code in the comments down below. So I hope that this video helped you understand what is recursion and how it works. And if it did, give it a thumbs up and subscribe to my channel. And also, you can follow me on my other social media if you want. The links are in the description. Thank you very much for watching. I'm going to see you in my next video. Bye! Hi everyone, welcome to my channel. My name is Saldina and I make IT and programming related videos. So if that is something that is of interest to you, consider subscribing to my channel and give this video a thumbs up as well. Now, in this particular video, I want to talk about object-oriented programming. So what is object-oriented programming?